what is the expectation at the end of at the end of your submission, final submission, when you do your dissertation. The university has this mandate that your document has to be in APA format. Okay, to come back to the assignment, this is a very introductory assignment, just to make you think about uh, how you can integrate emerging technology with AI with your business problem. It could be any business problem. It's not that you have to think about a problem and you have to take it forward till your end. Nothing like that. You may have 10 ideas right now. Maybe you can explore any one idea at this point of time. But when the way the assignment is created is how you would be thinking about integrating AI in your final research question. That would be definitely a business question or a problem that you're trying to solve for the society. So it is based on what are the things that you need to consider. If you integrate a technology, the first thing you should understand what would go wrong, and that's how you should develop the integration. We always look at how it's going to be beneficial, but when it comes to business, we should also see where is this going to fail, and you should be prepared for that. And that's how you should, work when you're thinking about integrating any technology, because that could be a major concern. So guardrails, responsible part, yeah, acceptance part, adoption part, and where all we have challenges. So everything looks good. Definitely, when we integrate technology, you see a lot of positives to it. But when it actually comes to the business, we should also look at what are the things that we should pay attention to and what can fail. Now, that's the whole idea. So that's how we want you to think about this whole work. So when we look at the assignment, I've told you how you build this assignment. I shared this assignment on day one with you guys. So that's why I made it into tasks where you could start thinking about a domain or a use case. Now, for this assignment, I'm okay even if you think about a very broad topic or a very broad domain like healthcare, or developing some integrating technology for making a smart city. You can have a very broad domain, and within that broad domain, you can identify a use case. Or at a high level, also, if you are right now proposing, I'm okay with it. So ideally, we ask you to choose one particular domain and narrow it down to a particular use case which you would want to solve. So that's how finally we narrow down a research question. But for this, as I'm telling you, you can have a very broad domain also. So you choose what is your domain. Ideally, it should be what is comfortable to you, the area in which you're working. Okay, now that's the first thing. Second part of it is the strategic problem framing. So not only from the technological angle, but you should understand uh, implications. When you look at the problem, you have to look at the business problem. How is it? How what is the problem from a business angle? And even if you're giving a technological solution, how is the business going to get impacted? Or that's how you have to create a path from a technology to the business. So the current or operational or strategic challenge that you're trying to solve, why existing systems are not sufficient, and what are the reasons. I mean, how, if I say it's not sufficient, in what way it is not sufficient? So why do you think that you need to bring in the AI? Do you really need to bring in AI? Do you really need to bring in a technology? You must be bringing in those technologies because you're solving a problem. So that's something that you should bring out here. You can come up with a problem statement. You can come up with what are the implications, what are the business impact if it is unresolved. After this, you have to come up with the emerging technology architecture design. That is, if you have chosen a particular problem, you need to create an architecture. So morning when I was talking, there was a question on task 3 and task 4. It is overlapping, but I would still put it like this. You here, it's an structural diagram. Architecture is a structural diagram where you put all the blocks that you require to solve this particular business problem. So you can come up with a coherent emerging technology architecture. For this, you can choose two or more. or only one, I'm still okay, but I'm sure you will require two or more. You have already studied a lot of technology, so you can choose two technologies and make an architecture of around the business problem. What kind of architecture you require to address this particular challenge. Now, so when you do this, you have to tell us why you chose these technologies and what is it that you're going to be solving with this technology, and why is it critical to the chosen use case. So that's just to give you an idea. You must understand why you are choosing this technology, what are the challenges, what are the risks. So you need to provide us with an architecture uh, diagram and a description, brief description. So this is about how say um, the technology and your business problem. Where is it? How are you going to create an architecture around it? Now the fourth task is system workflow. Now, if you're looking at a very broad problem, then architecture is sufficient. But if you're looking at a particular use case, architecture, there's a very small difference between architecture and workflow. In a workflow, you put all these blocks in a sequence, and how the data flows, or how the entire task that you have decided to do with the technology is going to flow. Is you may have, the direction in which the data moves, or the sequence in which the processes are going to happen, bi-directional, unidirectional. So there is a slight difference between architecture and workflow. But if you're right now proposing a very broad framework or something, I'm for this particular thing, I'm okay if you club the task 3 and task 4. But as far as possible, try to keep them separate, because one would give you how there is a flow and it has to be in sequence. An architecture diagram need not be a sequential diagram. Okay, so I want specifically, if you make an architecture, you need to create a diagram where the data flow happens. After this data's flow, flows, you validate it at this point, then it goes back into your system. How are you building at this point, the test check is done. Okay, the validations are done. If it is not validated, then what happens to the data? How does your technology take care of all those? That's what we want. How is this in the decision making? Where does your entire system fit in? And task 5 is, every time, as I told you, governance, security, and risk are the biggest things in when we are looking at any AI technology enabled solution. It looks good, it's very helpful, they solve your problem. But with every technology integration with the data, you have data governance, you have data bias. How do you use the data? Especially in generative AI, there are multiple challenges with data. What are even with any other risks are involved, security is involved, privacy of data is involved. Anywhere you bring in technology, you are collecting data from IoT sensors. What is the kind of governance you're maintaining, because you are also having a lot of data exposed to multiple stakeholders. So how are you going to build this governance, security, and risk into your system? You can provide a governance model, you can do some kind of minimal risk sometimes we have, but yeah, you can, how would you mitigate it? So some of these aspects to be covered. I'm just giving you some help, or these are not that you should only stick to this. You can have your own thoughts, but the primary thing is pay focus to this. Sixth is the value and strategic impact. How have, in what way it has solved the problem? Has it improved efficiency? Has it reduced the cost? Sometimes it may be costly, but it may produce a better output. So there's a trade-off. There may not be, you may not always save cost in every problem that you solve with technology, but yeah, you may increase the speed. Eventually, it will reduce the cost. So you will have to do an analysis on how are you going to, what impact immediately it has, long term it has. You can think of it in those lines. And once you know this impact, your KPI outcomes, how would you measure this? So I say that, okay, my model is very accurate. I have created a classifier model which is classifying cancer and no cancer patient. But ultimately, it leads to some KPI. How do you measure that? How do you measure? Is it okay if I measure how many cases it flagged as correct and the model is 80% accurate. No, but I have to look at how many actually the cancer patients got help from this. If say there are only 1 out of 100, and if it doesn't flag that correctly, then the way we are measuring is maybe to be relooked at. Or there are many things when we actually translate all these technological measures into business measures. Efficiency, for efficiency, means different for different people. So we need to bring that back into the or at the organizational level. And so yeah, that's it. So you need to create you choose a topic, whatever you want, understand that's your domain, identify a use case, uh, create a strategic problem statement around it. Why do you need this to be solved? Then which technology, how are you going to solve? What technology are you going to use? What kind of architecture you're proposing? How would the data flow in this architecture, or the process happen sequentially, or how are you going to plan to do this? What are the guardrails that you have built into it? What are the challenges that you need to look at? That's the sixth task. And how does it impact, not just in terms of technology, but also in terms of the business? So now coming to so this is all about what you have to do. You stick to 2000 to 2500 words. I will not cut your marks if it goes to 3000, but don't go beyond that. And or it is 1800, we are not going to cut marks. The reason why we want to do this is we want you to understand that the same things can be done in 2000 words, and the same thing can be explained in 7000 words. And how do you do it? It depends on, this is also part of your research writing, that how do you write something in, maybe in a poster, in a presentation, in a 2000 word document, in a 5000 word document. You still need to communicate your idea. So the idea of keeping this word limit is that you learn to communicate your idea in very few words. So the solution is try to have more diagrams, more uh, infographics, and less of narratives, so they are self-explanatory. And yeah, so that's it from my side. I'll share a APA formatting guideline with you. As far as possible, please follow it. If you can't follow it, I'm going to definitely come take a session, and I'm going to give you a small activity of sharing one document with you, which you can convert it into APA and share it back with me. I'm planning that because as we are moving ahead in to cohort 10, we already have 5 cohorts in dissertation phase. We are facing this challenge, so I want from day one this APA thing to be sensitized and told to all of you. So I'm not really going to penalize you on that, but soon I will be sharing one document where I will give you guidelines and you convert it into APA, which will be a non-graded, but it will be helpful for you, rather than me going through a PPT and explaining to you, which doesn't help, which I have realized in from last few cohorts. So I will be doing that separately for you. Yeah. So I'll pause here. From my side, this is the explanation. These are my expectations. I'm okay to take questions. Yes, Sandy.
Yes, good evening, Professor. I want to ask about for the 3,000 words, is this include the references
No,
or not?
no,
Not include,
not
only the
including
content.
references. Only
That's
the
great.
body of the content. If you have title pages, nothing is included. It's always the body of the content, not even abstract.
Thank you very much. Thank you. So if I want to contact you to ask about something for the assignment, so I send which email? Because I've
You
sent an
send
email
it
to
to
you.
student support, and I
Oh, so,
generally I respond faster if you send it to me on Upgrad email ID, because I'm always online on that Upgrad email.
okay. Thank
Okay,
you very much. Thank you.
Atif.
Thank you, Doctor, for the explanation. If I might ask, is there a minimum references that you want us to
No,
go through?
no. You may not require many. Maybe you can have, because where you are going to cite something about technology, why you chose.
Yeah.
I feel that you can manage it in 5 to 10. You won't require anything more. You can refer to company reports. You can refer to case studies. You can refer to published literature. I'm not wanting to do everything in the first assignment, basically.
Thank you, Doctor.
Yeah, Prince.
In case if I want to explain something with some design documents or a flow, right? So because explaining anything into a detail and into a textual format sometimes it becomes difficult. So in case if I want to include some diagrams or
Yeah.
can I do that? Yeah.
You can. Yeah,
Okay,
you
perfect.
have to use diagrams. That's what I said. You use diagrams, and then you can. That's
Yeah.
a good way of explaining in 2000 words. You can use AI tools to create your diagram. If you're using AI tools to create your diagram, please mention that you have used
Yeah,
this
definitely.
particular AI tool to generate this diagram. We will accept it. You are allowed to do that.
Okay, perfect. Thank you.
Okay. Yes, Nimesh.
Yeah, can we use like ChatGPT to proofread our written document, or we cannot do that?
You can do it, but it will become a AI. It will flag it as a very high AI content. Please
Okay.
keep a prompt which is replicating your persona. So
Okay.
don't the ChatGPT will generate a 100% perfect document. That's not the way we do it. So I think even Dr. Suresh can add something here. I will not eat into his session, but yeah, he can also discuss. You can talk to him at the end. He will help you out how you can use ChatGPT as a help, not to generate ideas, but
Okay.
to help you in
Yeah.
rephrasing and all. Yeah.
Okay. Thank you.
So
This is Atif. I have one. Sorry.
Yeah, thank you, Prof. Prof, I had a question saying when you started in task number 1, which is identifying the domain and selecting the use case, can I pick up a real life use case of a
Yeah.
real industry with a real company that's using a
Yes,
innovative
yes.
technology stack? Yeah, that's okay. And I can use
Yeah.
that company resources as my references because that company has been able to provide me a lot of their material on how they created architecture workflows.
Yeah,
So I
yeah,
can
yeah.
use that as my references.
Yes, yes, you can
I'll
do.
obviously give the citation for that
Yes,
company,
yes.
but it's possible.
Yeah, I mean,
Oh.
yeah, in all fairness, we should do that. But yeah, you can take a real world problem. You can think about multiple problems that you would maybe want to take it up as your research work.
Right.
I always say this that, and Suresh is also there, he will agree because selecting the topic is the most difficult part in a research. If
Right.
you are very clear on your problem and understand your topic, you know what to do.
Got it. So
That
my
may take
concern,
time. Yeah,
got it.
yeah.
So my concern was that, the company has looked, it's a slightly niche topic because of the way the company has adopted technology. That won't work against me if it's a niche way that they've looked at it, right?
Done.
Okay, got
No,
it. Thank you.
no. And
Thank
in fact, I'm even open. If you want to use any other technology apart from this, maybe somebody wants to use a voice assistant, I'm okay with it. You don't have to limit yourself to the technologies that we have covered
Got it.
or that we are going to cover. If you have
Got
some new technology, it's good. I will add it for my next cohort, that technology, if it's relevant.
Got it.
So we
Super.
are very open. We are to all these types of inputs from the learners.
Got it. Thank you, Prof.
Okay, I have a question, Dr. Smith. So I think you answered my question, but I just want to make sure I'm on the right path here. So for domain, for example, I selected smart cities, which was listed in your document. And for users, I was considering property taxation. And when I talk about property taxation, can it be from the perspective of the municipal government? Or
Yeah.
Okay, it doesn't have to be from the side of the
Yeah,
business.
I want to make one thing very clear in this, that in all the course assignments, we never get involved in the topic. Even here, smart cities is just an example I gave. If you want to work on anything else, you can do. In all the assignments, we give full freedom to the student because research, that's what is research about. We don't give you the topic. You work on your own topic. It's unlike the other PG programs. They'll say, okay, take this as assignment, work on this, give me this. It's a challenge for all of us because as a instructor, as a grader, as professor, to read multiple topics. But that's how the entire program is, where the professors are not going to say that take this and do it, except the technical problems. They will say, take up a topic, choose your own topic and work on it. And you should start thinking about the areas that interest you. So it will help you at the end in creating
Okay,
your own topics.
So even when
Right?
you say business problem, it could be the problem that we are solving for a government.
Yes, absolutely. It can be a societal problem, it can be problem for government, it can be a business, but it can't be an individual problem. Like example, if I'm trying to solve something if for patient, okay, I'm saying I'm giving a patient experience, I'm improving, but how does it going to go and fit into my healthcare domain? It's very important. Say I solve a family problem, but can I make it as a part of a policy in the legal document? So we need to extend that. You can't solve some problems which are very education related or medical. So even here, when we have a technical problem, say I'm trying to help the company choose the right kind of the AI tool. Okay, you come up with something maybe for education, you're creating some tool and you're going to give some platform where you can choose. I can't do this because it's a tech problem, you're giving me a tech solution. But how does it help the education sector? Or can you build a framework where the education sector can be benefited? It becomes a societal problem then. So even the tech problems, we allow students to take it. But then the implication has to be the business implication or societal implication.
Thank you very much.
Yeah. So we have people working on a GPU design. It's a core technical, but we permitted them because it's going to help in cost. It's going to help in computation, which is a major concern right now. So yeah, we do allow such things. Okay. Okay, so yeah, I think I have answered. Dr. Suresh is also there. You can ask him if some question pops up, or you can reach out to me if you have any doubts on the student support. And on my grad ID, I had shared with you guys. Keep me in copy if you want. And if time permits, I'll request Dr. Suresh if you could help them on how they can use the prompts ethically and
You know
in a way where.
what is going on in my mind is I'm so happy to be here. Like if you are taking some lecture, I'm so happy to receive and posting some questions. Again, it's a weekend. It's not at all easy to preach or teach, whatever you can call. Okay, so seriously, I don't know how to break the barrier in the weekends. Today morning, I thought like it's a sleepy morning and all. Even now, my eyes are actually reddish. I don't know. There is no difference I can feel now. Morning also, yes, it is not easy to take. Now also, I felt sleepy again. I don't know why. Maybe based on your experience, yes, you can give some input now. How to break this barrier?
That's a separate conversation, Suresh. Yes, I will. I will share.
Sure.
Yes, I'll do that. Yeah. Okay. Thank you, Suresh. Thank you for the time.
Yeah. Thank you.
Okay.
Ma'am, are you going to be doing
Right.
assignment 2 as well?
No, right now assignment 1. I'll come
Oh.
back again to discuss assignment.
Got it, got it.
Okay. Bye-bye.
Bye-bye.
Yeah. Bye, ma'am. So good evening, good morning, and maybe sometimes good afternoon. I don't know. Like as I discussed with the prof, is it easy to break the barrier in the weekend? How to start the session? I don't know. Give me some idea how to take over it.
It's all about motivation to do something.
What to do? Something means I am
Something
the,
that
like
that-
if you are, yeah, if you are lecturing and yes, absolutely, I'm ready to listen. So that is what the mindset now I had.
well, I can share one experience while I was into my engineering. And the
Oh.
professors, because we used to be into college campus itself.
Hmm.
And early morning, our professors asked us that if you want to learn something, you have to get up early in the morning and start learning during that period of time, because that allow you to learn from from very fresh mind. So, and for that, you need to have a motivation that you have to come. You have to start your day when most of the people are sleeping. It means you are 2 hours before than them, right? So, and mostly in IITs generally, because I'm coming from there. So we always used to study late in the night, because during the day we always try to do a chill across the campus. But during the night, our groups were starting discussing the problems that we had during our classes and whatever we have discussed. But taking a challenge that starting our day in the morning and in front of and presenting that during afternoon in our lecture room, that actually gives you a motivation that okay, you did something really good because you had a very less time, but you did that.
So, like, it's more formal way of like, it's actually your response is more formal. So, any other responses? How to break the barrier during the starting of lecture?
I think maybe start with your own story.
Yes, absolutely.
Start with your own story. I mean, it's the easiest to call to mind. You're picking your own story, so you're drawing from your own center of excitement. You
Yes.
know, you get excited retelling your own story. We get excited, drawn into it, and then from there, you guide us to the study area that you want us to go.
Yes, absolutely. Yeah. Okay, we'll start the session. So before get into the session, I just want to know about the participants. I know the participants are from various domains, either maybe a CEO, CTO, CFO. You may be from the marketing or finance domain or pure technical domain. Yes, we had a like various audience and from various domains. So it is better to understand the participants with the help of some small quiz. Okay, I have posted the quiz, like the link in the chat box. Please go through it and complete the quiz. It's just a 5 question MCQ. Try to complete it within some 2 to 3 minutes. It would be better to move forward. Is it accessible? Yes, thank you. So out of 33, I got only 9 responses till now. Please complete it. Now it is 12. So shall we start? Has everyone completed?
Yes, sir, we can start.
Okay, we'll start. I hope, yeah, the time is enough. So how was the question? Like, you can able to answer all the questions rightly, or what is going on there? Maybe 3 out of 5 or 2 out of 5. What is your score now? Am I audible?
Yeah.
Okay. Oh, so those who got 5 out of 5, very bad. You are not the right person for this lecture. Okay, it's enough. Don't post the scores hereafter. So I think then maybe so mostly the technical persons are in this crew, I think. So that's the reason you got 5 out of 5 for this. Okay, so it is really hard for me to take over the session. So am I right?
No, sir, we have a number of non-tech background. I think you're only seeing. I think people who got 5 are posting the scores, but
Okay. So if the yes, absolutely. If the reply or the response is like 2 out of 5 or 3 out of 5, seriously, I would be more happy than that of 5 out of 5. Yeah. So the technical people for them it may be like a boring lecture, and because to understand HPC, that is high performance system, we have to understand how the simple system, that is the how the computer system will works. Let us take a simple desktop system or laptop system, how it works with the help of the basic hardware units. So the understanding of hardware units, yes, then we can understand easily the HPC, how the HPC will works. Okay, so this is how that we are actually having the presentation. And as a technical guy, it is not easy to explain HPC without any demo, or usually we'll take a cloud or a LLM creation or agents creation with the help of some program with a demo or some output. Okay, so when the participants are there, it is easy for them to understand if you have a demo, because demo is the response or it is the outcome or output. By seeing the output, they can easily understand. But what will happen in this HPC lecture means, here we are not going to program anything. Here actually we are trying to understand what is HPC in terms of AI project. That is like AI project means whatever we are doing for the thesis I'm talking about. So maybe AI framework or agentic AI creation. So whether HPC is needed for our AI projects or not. So in this perspective, I'm going to take on the lecture. Okay. So I hope you understand, like, so this is not about the program and output the things. Okay. If it is, I will be more happy. But anyhow, fine. So as of now, all my lectures are actually had it well went. Okay. So I hope it would be the same even now. Yeah. So HPC, I don't want to expand the same thing again, like high performance computing. Yeah. So let's get into the session agenda. So we are going to discuss about starting with like basic components of system, then evolution of computing, then HPC architecture and its significant, then the case study. Along with we are going to compare with like how the CPU, GPU differs from each other, how HPC cloud will differs from each other, in what cases we have to prefer GPU or CPU or HPC, like that. What is AI with respect to that? What is the reason for having, why we are relating AI project with HPC or GPU and CPU? Like this, we are trying to touch these terminologies and try to differentiate each terminologies and what is the boundary of each. Like we are trying to relate all these terms together in this lecture. Okay, so this is how we are trying to take the lecture, and let's get into the starting basic components of system. So again, most of you may have the have good understanding of components of system, that is basic components of system. System means it's a computer system I am talking about. Okay, maybe let's see. So if you pose the questions for the okay, I will get into that directly. So what are the basic components of system, or what are the core components of computer system? So the core components may be a storage, then memory, then processing unit. So throughout this lecture, sometimes I may use the word, or I may use the term storage, or I may use the term HDD or SSD or NVMe. Everything is same. Not exactly same, but all HDD, SSD and NVMe are storage unit. Then memory. Memory means, according to computer system or laptop, let us take, memory means RAM or ROM. But in this lecture, we are going to discuss about only RAM. Then processing unit. Processing unit, yes, CPU or processor, both are same. Sometimes I may use the word CPU, or I may use the word processor. Okay, so this is for your understanding. First of all, so these are all the core components of computer system, like storage, memory and processing unit.
Sorry to cut you, sir. Are you sharing your screen?
Yes.
No, we cannot see.
Yeah, we can see it. I can see it.
Yeah, I can see it. I can see it.
Here we can see it fine.
Yeah.
Not sure. Let me just.
You may sweep to the left or the right to see
Okay.
the screen.
I mean, there's a tab which is study abroad screen. You want to maybe select the two tab.
Oh, okay. So it's not my problem. Shall I continue, or I will stop share?
Please.
No, able to see.
Yeah.
Yeah, please continue. So,
Thanks for resolving the problem. Yeah, nice. Yeah, so we are going to start how this storage, memory and processing units are working together to solve the computation problem, or to solve the problem. Okay, for example, storage means, let us take HDD, hard disk, HDD, and RAM, that is memory, and CPU, that is processor. How these are actually working together to solve the problem. Can anyone give some example how this hard disk, RAM and CPU are working together? What is the relation between these three core components of computer system? With some example, yes, you can point it out. Some quick answers, please.
So easiest example is in a PC at home. You've got a PC at home that has all of these three components that work together to run an operating system and all your day-to-day applications.
Yeah, exactly. Yeah, that is what actually we are discussing. Like all the computer system or desktop system has these kinds of core components, and how this related to, try to relate this based on the computation.
It is like studying for the exam. You have a textbook. You also have a jotter book where you keep your keynotes, right?
Okay.
So CPU is your brain.
Okay. Yes, then again it's an analogy. Then those who are 5 out of 5, please, I need your support for throughout the session.
Nice. Another simple example is like you have a large file, so it's like storage. It's a million rows file, which is an Excel file. You have to store that file somewhere. This is HDD. Now we are trying to query that file and or do some processing, like doing a VLOOKUP or something of that sort, which is, I guess, your CPU. But you're using like some keywords or like some key functions, and that may be the RAM. I'm not sure about that, but yeah, just trying that short-term memory to query HDD and get your output.
Yes, nice example again. Good.
Is it also safe to say that the CPU really only works on RAM? So you kind of have to pull something into RAM, just because CPU kind of you grab the information from the hard drive, but then the actual work is done based on what's in memory. It doesn't, you don't actually work on the hard drive stuff. You work on what's in memory. And then when you're done with it, you put it back to store it.
Yeah. One more example, anyone? Fine. Yeah, I will take the second example. Like hard disk is the dumb storage. Yes, we can store everything in a hard disk, and it's a permanent storage. And yes, those who are Windows user, yes, we know very well. Like, so we had a drive like C, D, C, D, E, and all. So this is how we can divide the drive into the partitions. That is hard disk into the several partitions, and we'll store our data into that. So let us take, we had a file we had a file. The name is a.xlsx. Okay, it's a Excel file. If the file is available in HDD, that is in the hard disk, then we call it as a, let us take, this is a passive program. Okay, it's a file, it's a passive entity. Whenever you interact something, like if you try to open the file, then the file is actually opening in RAM space. The file is actually opening in the RAM space. So that is what we mention as the process. Like this passive program is getting into action called active process. Okay, so it will be coordinated by CPU, whom to fetch, where to put it into the RAM space, etc. So likewise, the coordination is actually done by CPU. And yeah, even we are going to cover how the CPU, like what are the components or registers available in the CPU, how the actual or unit operations will take care by the CPU and all. As of now, let us take one more thing, like CPU has its own memory. Like let us take the memory name is cache memory. Okay, if the file is available in the cache memory, for example, whenever if you are try to open a file a.xlsx, then always the CPU looks at the cache memory, whether the file is available in the cache memory or not. What is cache? Cache is a memory which is available inside CPU. Okay, so it will looks at CPU, that is CPU looks at cache memory first. If it is not available, then it will search in the RAM space. Again, if it is not available in the RAM, then it looks at hard disk to fetch the file. Even it is not available in the hard disk, that is I'm talking about the storage, then error, it rises an error. So this is how the interaction between hard disk, CPU and RAM would be. Is it clear?
Yes, sir.
So what is cache memory?
Sir, does cache memory sit in RAM itself?
No, cache memory is in like processor. Inside processor, sometimes there are some types of cache memory like L1, L2, and L3, and few are actually reside inside CPU, and few are in between, like resided in the motherboard between RAM and CPU.
Okay.
So what is cache memory? Why it is faster than, for example, let us take, if you try to access the file is in cache memory, it takes some, let us assume that it takes some 1 millisecond to read the file. If it is in RAM, 5 millisecond. If it is in hard disk, it may be 10 millisecond. Okay, why cache memory is faster than other two?
Because that's in CPU.
Yes, one thing, it is resided on CPU, and What is the purpose of cache memory? You know, like hard disk, maybe
It's
one.
a,
Yeah,
it's
sorry.
a temporary storage.
Interruption. Yeah, let's try to pitch
It's a
one.
temporary storage.
Yeah, sorry for the interruption. One more thing. Okay,
It
so
actually
yeah, usually the size of hard disk may be up to 1 TB nowadays, and the RAM maybe nowadays we have some 16 to 32 GB of RAM in our laptop, but cache memory is in terms of MB, not in terms of GB and all. But cache memory plays a good role or significant role while fetching the process or while like retrieving the process. Okay, it is also fastest memory. It is the fastest memory. Now tell me, like, is it okay to increase cache memory further?
will not. That
If not possible,
the,
why?
the way cache memory works, it actually does not contain the complete process data packets, and it actually rather it actually, and then there is an application.
Uh,
Multiple applications are running, then it takes.
so your voice is breaking. Sorry for that. Any other answer? Those who are, please put your responses in the chat box. Please try to unmute and talk, because it is easy not easy for me to every time to look into the chat box and respond. Okay, so please unmute and please be interactive.
Close down the CPU, sir. If you
Energy
have more.
consumption?
Yeah, based on
The volume of data.
yes, like as we discussed, cache memory is inside CPU. Then what is the core job of CPU? Computation is the core job of CPU, not like it is not a storage unit or it's not a memory unit. It's a small memory unit that holds the recent process. For example, if you would like to play a song again and again, that song may be like, let us assume that song may be a.mp3. That a.mp3 may be available in the cache memory. Then it is easy to fetch from the cache memory. That is what recently we have played. Okay, so the CPU will easily fetch the a.mp3 from cache memory if it is available. If not, it will search in the RAM space, or if not, it will search in the hard disk. Okay, this is how it will works. Okay, so the cache memory is used to store the recent data, not for all the information or all the process. So again, it is resided inside CPU. It is not possible to increase the memory further, because nowadays the chip, even the chip is smaller, and the weight of the chip is reduced so much, and even the gap between each transistor is actually 2 nanometer. It is not possible to increase further nowadays because of, yes, absolutely, someone mentioned in the chat box, yes, because of heat dissipation problem and etc, maybe multiple reasons. Okay, hardware limitations are there. Okay, so it is not easy to increase the cache memory which is resided on CPU. That is, I'm talking about the processor chip. Okay, even though it is a, yes, fastest memory. Is it clear now? What is the use of cache memory and why it is not possible to increase like 16 GB RAM or 32 GB RAM or like hard disk 1 TB and all?
So how does the system decide what has to be in cache versus not? Because is it more frequently used data or the most latest data?
No, we had everything will be fabricated during the chip manufacturing. Like everything
Okay.
will be, yeah, it has its own algorithm. Maybe if it is filled, then it will be replaced with the help of some algorithm, least recently used or most recently used, like that. It follows some policies or procedures. Okay, that's how it will be replaced.
Okay. So every manufacturer will have their own logic, is it?
Yes, absolutely. So based on that, the cost may vary. If you had high cache memory, absolutely, for let us take some, if you had some 256 MB of cache memory, it will be costliest.
Okay.
it's not easy to get it again.
Got it. Sir.
Question. So for GPUs and these other technologies, would that mean that the architecture would be, well, essentially, if I'm, the whole concept of a GPU means like I'm doing parallel processing. So would that mean I would have significantly more cache?
Yes, I will
Or
come
is
to
it just a totally
yeah, I will
different
come to the
concept
GPU.
altogether?
Sure. I will come to the GPU part after completing the CPU things, because there is a little difference between CPU and GPU, and even like CPU and HPC and all. If you understand how our systems works, that is the desktop system works, then it is easy for us to relate how the HPC and all the computation build on. Okay, surely I will come to that point later on while discussing the GPU part. Okay, let's give you some more example based on like what happened in my maybe some, I think some 8 years back. Okay, so what happened to me is like I had a laptop. That laptop has uh, i3 processor with let us take some 16 GB of RAM, 16 GB of RAM with hard disk HDD. Now I would like to increase the performance of the system. What I have chosen is I have added, okay, we have not discussed anything about HDD and HDD, SSD and NVMe, right? So NVMe is fastest storage unit than SSD. SSD is faster than hard disk. Okay. So if you had NVMe as a storage unit in your laptop, then yes, it is the fastest thing. Like nowadays, the laptops comes.
You need to understand how to deal with these things. Hey, Chandra.
So this question is for
Can
me.
you hear us?
Yeah, I can. I'm in a session. Give me 1 second. I have to come out of another session.
Sorry,
Right.
sorry.
Okay, so nowadays laptops comes with the configuration of like how this like SSD. It comes with the combination of SSD plus NVMe. Okay, this is how nowadays the laptops comes with the storage unit. So what happened in my case is this is what I had actually. Now I have upgraded my storage units by adding 1 NVMe, that is non-volatile memory. Okay, non-volatile memory. It is also a storage units. So I had now 2 storage unit, that is one as HDD, another as NVMe. Okay, so to increase the performance of system, performance means I'm talking about the computing speed. To increase the speed of computation, I have chosen to upgrade my storage unit instead of upgrading my processor, or instead of upgrading my RAM, that is memory of RAM memory. Okay, so can you give me the reason what happened to me, why I have chosen NVMe to upgrade my system instead of upgrading my RAM as well as CPU?
Because the NVMe speeds up the rate at which you can swap data in and out from the RAM. So you can essentially handle much, much more, even with the same RAM.
Okay, then it's also a storage. Actually, it is not RAM. It is looks like RAM. Like if it's look like the shorter version of RAM. Okay, it is almost look like RAM. Yes, we have to fix it in a slot. It is not the purpose of NVMe and the RAM. Yes, absolutely both are different. One is a storage unit, another is a memory. So why I have upgraded NVMe, that is the storage, instead of upgrading RAM, that is memory as well as processor. What limitation I had?
Access to data.
Can you please explain more?
If your objective is only to access data,
Oh,
And
okay.
yeah, and
So
then
use case
NUMV would work, but it's just purely to access data, but the processing power is still the same.
okay. Other than that,
NVMe matters because the program will start faster. The files will open more instantly. There'll be less lagging.
yes, absolutely. Yeah. So the question is very clear. Like, yes, everyone knows, like just now we have discussed, NVMe is the fastest among all these storage units. Yes, absolutely, NVMe is the fastest. And if you install OS inside NVMe, then the booting speed, yes, is absolutely, it will increase, as well as the files are in, like all the systems files are available in NVMe. Then this, yes, it handles faster than that of if it is resided on SSD or maybe in HDD. Yes, Prince, please.
What is exactly that way which actually makes NVMe faster than HDD and SDD?
So NVMe is almost the technology is similar to the RAM. Okay, it's a chip again. So our hard disk is made of, it's a magnetic disk. So the magnetic read and write, it's a mechanical device. So it lags behind than SSD. SSD is almost similar to the pen drive. Okay, so NVMe is almost similar to the RAM technology. So it has the speed of RAM. So that's the reason it is faster than that of both magnetic disk and yeah, similar technology like pen drive, SSD.
Oh, okay, got it, sir. Thank you.
So now the question is like, what stops me to upgrade processor and memory?
Maybe the i3 cannot support more than 16 GB RAM. I'm just guessing.
Yes. How can we say that?
I know that when the processors increased in size, that's when you could have more RAMs added. It's just a logic that I remember from past years. That's all.
Okay.
That's what I used.
Yeah, it's a right answer.
I'm not a computer expert.
Yeah, it's a right answer. Yeah, I just need something in simple terms. More than that. It's very simple.
Yeah.
How many of them have a chance to look into the motherboard of our system, computer system? Mostly it is not possible in laptop, maybe in your earlier days.
Maybe you don't have a slot in the motherboard.
So the motherboard limits or stops you from increasing the CPU.
So motherboard, yes, the CPU is the part of motherboard. So the processor is a small chip which is resided on the motherboard. Okay. Likewise, we have some 2 slots of, let us assume some 2 slots of RAM slots. Okay. So it is possible to have only 2 slots. So while fabricating, if they had only 2 slots, then we can fix only 2 RAMs in it. Okay. So for example, in my case, I had 2 8 GB of RAM in slot 1 as well as in slot 2. In this case, is it possible to increase my RAM further?
Yes.
Yes, absolutely.
No.
Yes,
Yeah.
so I can throw out 1 and I can push some 16 GB of RAM in one slot. Am I right?
Yes.
But what will happen to the 8 GB which is already in the working condition?
You have to dispose it.
Why I have to?
It should be added to
You only
the,
got
to the
2
whole
slots.
capacity.
Yeah, I
You have
had
only
It
2
should be
slots.
it should be added both.
Yeah, I had only 2 slots. It's not possible to add further.
Right.
Yeah. So I can have either the combination of 8 plus 16 or maybe 12 GB.
16 plus
16 plus 16.
Yeah, or 16 plus 16. That's all. So that is the possible case, right? So in a simpler way. But in that case, what will happen means I'm going to waste this working condition RAM. There is the memory. Maybe I will kept idle in the cupboard. So it's not the ideal solution. Maybe that time I may thought like it's something it's not a suitable thing to upgrade my system based on the RAM. Almost 16 GB of RAM is enough for that time. Okay, I'm talking about 8 years back. It is more than enough. Okay, then coming to i3, is it possible to upgrade like the processor which is resided on a motherboard easily?
No,
It's
it's
soldered,
not.
it's soldered onto the motherboard already. It's not removable like a Lego.
Yeah,
Yeah.
but every
It's soldered.
motherboard support some model or some socket model only. So I may be it may be limited the model of the CPU, so you cannot operate it easily.
Yes. So there will be some compatibility issue matters. Like sometimes the Giga board maybe supports for, like, let us take for i3 means the same board won't support for i5. In that case, I have to replace both motherboard as well as I have to take a new processor. Let us take i5 in my case. Again, it's not the ideal solution for me that time. Okay, so that's the reason, because of this compatibility issue and because of this some fixed RAM slots. Okay, so I have not preferred to upgrade my processor as well as my memory. So that's the reason it is easy to have some add-on in by having hard disk plus NVMe. So I have kept all my OS, like I have tried to boot OS through NVMe, and I have stored all the other files in HDD. Later I have upgraded to SSD. That is a different story. But yes, this is what happened 8 years back. Is it clear like how the systems works?
Yes.
Yeah.
You've given two sentences again, a short recap. It's just short takeaways. Yeah, but it is enough. We understood, but it's nice also if you repeat in 2 sentences, short takeaway.
And like okay, let's give me try to give you one more insight. What is the reason? Assume let us delete this one. Why RAM is also a core part which actually determines the speed of computation. For example, if you had some 8 GB of RAM, then, or if you upgrade from 8 GB to 16 GB of RAM, then the speed of the computation may increase. What is the reason, or what is the relation between speed of computation and RAM?
Read write memory.
Yes, RAM memory. Then
Because it stops the computer from waiting.
exactly. Give me some more explanation on it.
It's like a kitchen table. 8 GB is a smaller table. 16 GB is a bigger kitchen table.
Okay. Anyone? Any other examples?
Well, to follow his example, it means you have to go back to the cupboards less often. Go back to the cupboards less often to find what you need. So the less trips you have to make to the hard drive, the faster you can process what you need. So you get tasks done faster.
Yeah, like, so for example, if you had some 8 GB of memory, I'm talking about RAM. If you had 8 GB of memory, let us assume that like if you had a huge file that is all about some 24 GB file, is it our RAM space able to accommodate this 24 GB file at once, at a stretch, in a single snapshot?
No.
Absolutely not, right? Even the RAM space has some system programs like OS programs and all. It will occupy few space. let us assume in our case, we can able to use all the 8 GB together. No, it is impossible. Then usually how the RAM process the data or process this kind of like information, whatever it get into the space. We had 24 GB of file. How to process this with the help of 8 GB? This is how the RAM will works every day.
It will create a temporary file. It will create a temporary file.
Yes, it creates a temporary file. Okay, then
the temporary file, the size of the file is smaller.
Okay.
It will use the HDD as a hub.
Okay. So
it will use the hard disk.
Yeah, usually this file will be divided into like multiple blocks. Let us take, since it is a 24, let us take for our convenience, we'll take 8, 8 and 8 GB blocks. Usually the block size is very, very, very small. For our convenience, I have taken 8 GB as a block size. Okay. So for our case, since 8 GB RAM, so it will try to like carry out the first block. Then after the completion of execution of the first block, then it will swap out the first block into hard disk. Then it will swap in the block 2 into the RAM space. Again, this will repeat again and again. And wherever it will store the like, it's called something paging and all. Okay, wherever it stores the data in the hard disk, it is referred as a virtual memory. Okay, don't think too much about the virtual memory. Okay, we are trying to understand like this kind of swap in and swap out happens. If you had a 24 GB of RAM, or let us take some 32 GB of RAM, is it easy to accommodate 24 GB of file into 32 GB of RAM?
Yes.
Absolutely. So in that case, we had only less number of IO operation, this kind of swap in, swap out, swap in, swap out, etc., etc. While watching a movie, let us assume that what will happen. Sometimes we may try to listen the songs again if the song is too good. Okay, or if we may forward quicker if it is boring. So in that case, again the swap in, swap out, we may look at some file or some segmentation or some paging part, or let us take in like the block, whatever we needed, that may be reside on the memory, like virtual memory, that is in the hard disk. In that case, quickly it has to be swap in and it has to respond. This is how usually the works will happen between, like the interaction happens between hard disk and memory. Okay, so to reduce the number of swap ins and swap out, we need larger memory. Okay, for the less IO. That's the reason, like if the memory is increased, like if you increase the size of the memory, absolutely the speed of computation increase. Is it okay? Is it relatable? Like how the RAM is directly plays a role in speed of computation?
Yes.
So so we have clearly like discussed about how the storage units like hard disk, then SSD as well as NVMe plays the role in speed of computation. Then we have discussed about RAM. Now we are going to discuss about CPU. So how to measure CPU? That is CPU speed of CPU. Everyone will purchase the laptops, right? What about your laptop configurations? How many cores you have? For M1 may have some 8 GB or 7 core of CPU and 6 core of GPU. Maybe M4 may have some 10 core of CPU or GPU along with some 8 core of CPU. Am I right? How the CPU and GPU speed we can measure the speed of CPU. It is usually measured in terms of So let us take an example.
Gigahertz, really.
Yeah. So I'm talking about like P4 machine. So it's not i3 or i5. Okay, let us take a P4. In P4, the speed of CPU is, let us take Intel P4. The speed of CPU is 3.6 gigahertz. What is the meaning of 3.6 gigahertz means? What is giga? What is tera? Any guesses?
1.24 MB equals to 1 giga.
Okay, so giga means 10 to the power 9. Tera means 10 to the power 12. Then it will move on like peta and etc, etc, etc. Okay, so giga means 10 to the power 9. And hertz, what is hertz? Hertz is
Frequency.
yeah, it's a unit of frequency. Hertz is the unit of frequency. That is 3.6 into 10 to the power 9 cycles per second. So likewise, for every second, our CPU or processor can able to generate 3.6 into 10 to the power 9 cycles per second. It means each and every cycle can handle a unit operations. A unit operation means fetching some instruction from memory or pushing some instruction or data into like data register. Likewise, we have some unit operations. Okay, some atomic operations. Likewise, we can perform atomic operations with the help of each cycle. For every seconds, it can capable of generating 3.6 into 10 to the power 9 cycles per second. Okay, so let's try to understand what is unit operation by having I had few diagrams. I will show you how the unit operations look like. Is it okay? Like, is it relatable to understand how the how to measure the speed of CPU in terms of hertz? For example, if you had i5 machine, that is processor, this processor may have some 4 cores. Each core has 2.4 gigahertz. So 2.4 into 4 into 2.4 gigahertz. So that's the reason by increasing the clock speed, yes, absolutely, it will increase the speed of computation. So now I hope you can choose so among storage, what type of storage you will choose among HDD, SSD and NVMe?
Of course, if I have enough money, I will choose NVMe. But
yes.
I heard some of my friends doing their job in the data center. They still prefer using some magnetic dish like SSDs.
Yes, absolutely.
For
Yeah, SSD means yes, we can have a plug and play capability. Easily we can do the plug and play. And NVMe is actually fixing like a RAM slot. It is not possible to increase NVMe as like SSD. Also, yes, it is much costlier than that of SSD. And NVMe has its own limitation. It also has the fixed number of slots. Okay, so it is not possible to replace as like RAM. So usually it will comes along with the laptops comes along with the configuration of both SSD plus NVMe. Fine. Let's move on to yes, this is what we have discussed, like storage, RAM, cache memory, then CPU, then bus is the connection unit. The basic flow, yes, this is also we have completed. If the file is not available in the cache memory, then it will search in the RAM. If it is not available still in RAM, then it will try to fetch from the storage. Then after getting the file, yes, it will be coordinated by the CPU with the help of register. So this is what actually we have discussed. And then now we are going to start discussing about like the components which is resided inside CPU. Again, I'm talking about CPU chip, the processor. Okay, the memory actually present inside CPU is referred as register. The memory which is resided inside CPU is referred as a register. This is for our convenience, we are making this statement. Actually, the group of registers is referred as memory. According to electronics definition, the group of the group of registers creates memory, and the group of flip-flops creates registers. But for our understanding purpose from the hard part, it's easy to understand the memory which is inside CPU is referred as a register. Okay, as of now it's enough. Now, so what are the registers usually the CPU have? So the CPU have program counter, IR, MER, MDR and accumulator. Shortly we refer this as a PC, then IR, MER, MDR and ACC, that is accumulator. Okay, so what is the purpose of having PC, program counter? So program counter which holds the address of next instruction to be executed. It holds the address of next instruction to be executed. So what is IR holds means IR holds the current instruction. The current instruction is available in IR. For example, if assume that if the PC holds, okay, maybe I will explain by having the slides, it is better. Then MER which holds the current address, MDR which holds the current data, and accumulator, yes, it is absolutely a temporary memory which holds the intermediate data which is computed by the CPU, like. So it holds some intermediate data which is happening or which is coming out of the computation. Okay, it is better to understand. So the same like explanation is given in this slide. So it is better to understand with the help of this kind of fetch, decode and execution cycle. Okay, have a simple example. Okay, so I hope 20 and 30 will be my example. Let us assume that the value of x is 20 and y is 30. Now, how the CPU is going to process this x plus y? Now, let's start from the program counter. So what is program counter? It holds the address of, what is 10? 10 is the address. It holds the address of next instruction to be executed. This will be flow into MER and after that it will reach into the RAM space. After getting into the RAM space, then the control bus will issue the read signal. Then where from where to read? We have to read from the address 10. What is available in the address 10? In address 10, we had an instruction like LDA. This will be passes into data bus and it will be reach into like IR. Here, LDA 3. Likewise, it will reach. This is how it looks like. Is it easy to understand like how it will works? Like it starts from the program counter, then MER, then read signal. After that, it moves, the instruction will be move on to MDR. Then finally, it get into the IR. So we have what to execute. Yes, it is available in the IR. IR holds the current instruction. Now we have to decode the instruction which is available inside IR. So what is LDA? LDA means load data into accumulator. Accumulator is available in the ALU. Load data into accumulator from the address 3. This is the meaning of LDA3. Is it understandable? The sequences?
So can you explain it again, please?
Yeah. So it starts from the process counter. So every time this sequence starts from the process counter, program counter PC. So the program counter holds the next instruction to be executed. For our case, it starts with 10. After loading this instruction into IR, what will happen means it will be added, then 1 will be added to program counter, that is it automatically becomes 11. So likewise it will moves on increment, like the program counter will moves on like 10, 11, 12 likewise. Okay, so the program counter which tells what need to execute next. Okay, as of now this is the starting stage. It holds the address of, let us take next instruction to be executed. Now the next instruction is available in the address 10. What is available in the address 10? LDA 3 is available in the address 10. That will be successfully fetched by database because of read signal, and it will be holded by IR. Okay, so that will reach into the IR. Now it looks like this. After the completion of LDA, now this PC value will be incremented to 11. So if it is 11, then again the same process will continue. Like after loading the data, like what is LDA 3? Load data into accumulator from address 3. What is available in the address 3? 20. The value 20. The data 20 is available in address 3. That will be loaded into accumulator. Load data into accumulator from the address space. We have loaded the data from the address space 3 into the accumulator. After the successful decoding of the instruction, now the program counter will be increased by 1. Now it will be 11. Now CPU will handle 11. What is available in 11? Add 4. Add 4 means we have to add 4 in the accumulator. So what is in the address 4? Address 4 holds the value of 30. So 30 will be added in the accumulator. Then what is available? Now it will be CPU, the PC will be incremented to 11, 12. So what is available in 12? 12 means like store from the accumulator into, like, let us have here 50. So whatever value is available in the accumulator, that has to be stored into the memory space 5. So the 50 has to be stored into the memory space 5. This is how the simple z is equal to x plus y will compute inside CPU with the help of address bus, data bus, PC, accumulator, and RAM space. Is it possible to understand? If you understand some 50%, it is enough to understand HPC.
Yes.
Actually, we are not going to build HPC in a semiconductor level, or we are trying to solve the problem like our AI project. The thing is, actually, we are not going to solve our AI project with the help of HPC. HPC purpose is something different. Even for the enterprise level AI project, not needed HPC in most of the cases. I'm talking about enterprise level project, AI project. Even that project doesn't need HPC in most of the cases. HPC is something different. Okay. Then your next question will be, then what is the reason for studying HPC, right? Okay, with respect to AI project, let us take. So maybe after the completion of the session, surely you may understand, like, to solve the AI problem, that is for our thesis, like HPC is not at all needed. Whether GPU is needed to solve our AI problems, whether GPU is needed,
Or an AI problem, to solve an AI problem.
in few cases, yes, it is needed. Okay, I will give you like one more example. What happened in our case? Okay, so 6 months back, actually, we try to create a simple RAG, that is a simple RAG system. So in which we are trying to train some 100 GB of data to create some RAG with respect to the Vedic mathematics. So to create a small RAG to understand Vedic mathematics, we'll try to, initially we have started with some 100 GB of data. Okay, so we have actually successfully completed training with the help of some 50 GB of data. And what will happen means, like, we have trained everything, that is this 50 GB of data with the help of i5 processor, 16 GB of RAM with 1 GB of graphics card. By using this configuration, I'm talking about only CPU, like whatever is available inside i5. Okay, so without any GPU support, we have trained this 50 GB of data in 45 days. Every day it runs 10 hours per day, the training or validation, and checkpoint we have given is 1 hour per day. Every 1 hour there will be some checkpoint. So even for LLM creation or simple LLM or RAG to train some, actually we are trying to our data is a simple text data. Okay, so in our case, the GPU is not mandatory to train or validating our problem. Okay, so but yes, if GPU is there, then yes, the duration will be very lesser than that of whatever we have faced. Okay. Yes. Is it clear? So
Sir,
what
currently you took 45 days. So if we use GPU, how much time would it take?
absolutely it will reduce, like, for example, again, it is based on the course which is present in the GPU. Okay. The what will happen is, okay. So it's depend on the course which is present in the CPU. Even in our first question, we have mentioned very clearly, like many of them has answered very rightly. I don't know how it is possible to answer. Those who are from the computing background or sometimes a technical background, they may have some misconception, like, so GPU is actually greatest thing than that of CPU, but it is actually not true. Okay, it's a myth. Again, yes, absolutely, CPU, yes, it is the master, and GPU are just a helper for CPU. CPU is mandatory for each and every system. GPU is actually not a mandatory thing. And when compared to the cost of CPU is actually cheaper, but the cost of GPU is, yes, it is actually costlier than that of CPU. Much more than that of CPU. Let us take some 10x which is costlier than CPU. So usually the TAM which is costlier, that will be the master, right? In general, the component, am I right or not?
You're right, sir.
So now our master is actually is very cheaper than that of the helpers. So what is going on here actually? What makes GPU is powerful? Try to spell out something.
GPU has the power of computational capability much higher, and that's probably why it's been used in AI, because it can, reason, inference capability is much higher, and so on. So it requires, if you require very heavy computational power, then you require GPU. Like in your example, 45 days with the CPU, with the current application and how technology is moving forward, you would require GPU, not together with CPU.
Yes. Yes, Prince, please.
So one thing I can think of that because the way GPU work, it actually because of it parallelly processes the multiple tasks at the same time. While in CPU, it actually takes the small thread of any application and then execute it and then push it back to the cache and then RAM. So that's why GPU, holds the upper hand because it has a parallel processing with it.
Exactly. So I will take a example related to this. For example, with the help of image analysis. Okay, let us take a simple image. So assume that a simple picture or image, it will be divided into some 256 blocks. And if CPU is processing those things, like with the help of i5, let us take i5. i5 may have 4 processor, like 4 cores, 1, 2, 3 and 4. Okay, i5 may have 4 cores. Then what will happen means, so the first block will be handled by 1 core, the second block will be handled by next, then the third and fourth. So we can process only 4 blocks at a time. At a time we can process only 4 blocks. Okay, in terms of GPU, if you had a GPU, what will happen means the number of cores inside GPU is actually higher than that of CPU. Like the cores which is available in the CPU, yes, we can have some 256 cores even inside GPU, so that we can map, one-to-one mapping will happen between blocks versus like GPU cores. In that case, yes, absolutely, it will be much faster than that of CPU with the help of parallel processing. That is, SIMD is happening. That is single instruction, multiple data. We can compute multiple data with the help of single instruction, because of the number of cores which is available in the GPU is higher than that of CPU. So that's the reason it is actually faster than that of CPU, but it is actually not superior than GPU, because the CPU is for different purpose and GPU is for parallel processing. If you are not having parallel processing, then there is no need of GPU at all. Most of the scientific application, yes, sometimes it doesn't need like the ratio of GPU and CPU may differ from use case to use case. I had a different slide for that. During that time, surely we'll discuss. Is it clear? Like how the GPU will support for parallel processing and all?
Yes.
Yeah, we have given the sequence of its decode cycle here, and let's move on to before getting to the evaluation of computing, it is better to understand AI. What is AI? So it's a silly question, as always the professors are posted, right? Or maybe in the corporate meeting, everyone is actually spelling the word AI, right? Every now and then. What is AI? Other than artificial intelligence, what is artificial intelligence?
It's a method to mimic human-like human-like logic to compute data.
Is it? This is how our AI applications are working. whether our AI applications are mimicking the human behavior? Do you think so?
Well, to the extent that they've been able to create models to replicate it, I mean, there's still a lot of things that they haven't figured out how to replicate. But to the extent that the bits and pieces that they've figured out, yes.
Okay. So usually what is AI or what is AI in the earlier period? That is, I'm talking about some 15 years back. So 15 years back, AI means, again, artificial intelligence means it is all about like robotic stuffs like bot. So if you are trying to create a bot or robots or how the locomotion or navigation of robo, then that is what artificial intelligence means. Nowadays, it is actually grabbed by the computer science people, and nowadays AI is equal to AI application. Simply, AI is equal to AI application. What is AI application? How it differs from normal application? Application versus AI application. This would be the next question. Whatever project we are trying to do, maybe these are all related to AI application, not about robotics or bot technology.
I think the difference has to do with how structured the instructions are. And how you came up with the logic to process the data in the first place. I think that's a big difference.
Yes, how the application process the data and how our data is handling in AI app. Like, yes, Prince, yes.
Well, one thing I can find the difference between AI and the normal application. AI has the ability to learn, and application don't have, and it actually works what it is for which it has been created. For example, if I'm having a calculator, then it will calculate only. But if I am having a AI-based calculator, it may find out the ambiguity or may find out different results, and it learn it, and next time it can produce a better results. Or maybe the ability of learning is the basis by which we can by which we can differentiate what AI and what a normal application is.
Yeah, nowadays even it is not easy or possible for me to give some good example for the applications, because all the applications are nowadays powered by AI. Okay, even few of them I actually mentioned in my lecture, like Notes is a is a normal application. It's not a AI application. Nowadays, Notes is also an AI application because it tries to summarize the text whatever we have given the input. So most of the application is AI powered application. Yes, as you mentioned, yes, it is very clear. So AI application means it's a self-learning application. It's a self-learning application. Based on the input, the output is varying. For example, like I don't know how how did you mention that calculator is an AI application?
So I was actually referring the scientific calculator, not the one, because recently I was actually doing some work, some financial calculation I was doing, and that's where I added some of the ambiguous data into it, and my normal calculator didn't come up with the expected result. But at the same time, when I actually utilize a calculator which is powered by AI, as you just mentioned, it actually first find out the ambiguity and explain me that what should be the data and how it should be structured.
Got it. Okay. Usually in Excel, we had such kind of recommendations. Yes, right. I thought you were talking about a simple calculator. So usually I will give an example for simple app. Calculator is a simple application. Even though if you use the same numerical value, it gives the same output. Even in my case, it gives the same output. Like that, I have given a simple example for the application. Calculator application is a simple application. It's not a AI application. Now I wonder so AI, yes, calculator also has a AI powered calculator and all. Fine. So you are talking about something differently, AI features. Fine. Like then coming to the point, like AI application is a self-learning application. How we refer this as a self-learning things means application means, yes, if I open my like Amazon, then it gives some recommendation based on my priority or based on my like whatever I have purchased earlier, purchase history, or based on my scrolling, mouse overs and all. Okay, so it may be different for me as it may be different for every others. Okay, how it learns by itself means it learns based on other history, based on our purchase history, etc., etc. But it is not in the case of normal application, right? This kind of AI applications tries to give some recommendation or suggestions. These are the products available, try to purchase this, that, etc. Even in our social media, we may got a recommendation like this may be your friends, and yes, these are all AI application. So these are all simple recommendation which is given by AI. How they have recommended these things? Yes, with the help of, like, this is what we have mentioned, like the beauty of AI application. So it can capable of doing learning by itself, that is self-learning. It is not possible in simple application. How this is capable of learning itself? Again, for understanding this, we have to understand the ML process. To understand AI application, then we have to understand ML process. Like simply data or data set will be the data or data set will be the input for ML process, followed by two major steps. One is data preparation, another one is applying ML algorithm, and the output of ML process is ML model. The output of ML process is ML model, and this is, yes, this is the output. So what is the input of ML process? Data or data set is the input of ML process. What is the output of ML like ML process? ML model is the output of ML process. What is the relation between AI application and ML model means? Like if you deploy ML model into an application, then that application will become AI application. That application is powered by, if an application which is powered by ML model, then it can capable of doing the self-learning. Okay, so this is what the relationship between AI application and ML model. So for every AI application, ML model or DL model, or simply a model, like ML or DL model is the core of AI application, so that it can capable of doing the learning by itself. Is it clear? Like how the what is the relation between ML model and AI application? I have not like clearly what is ML, how it looks like and all. I just would like to relate AI application and ML model. Is it clear?
Yes.
Okay, let's then move on to how the ML models look like. So we know very well the output of ML process is ML model. If you deploy this into some application, then that application may convert into an AI application. Okay, fine. How the ML model looks like means, for example, let us take some data or data set, a simple data which has two columns, one as a height, another as a weight. So the height of the person is something 170, 168, 165. Likewise, it will move on in centimeter, and the weight maybe in terms of tons or kgs. Like assume kilograms. The weight of the person, if it is 170, let us take some 78, 80. Likewise, we have some weights with respect to the height. So this is what we referred as the data or data set. which will be the input for ML process, which will be the input of ML process, and final output. How the final output means, like for example, AI application, AI app may predict, it has the prediction capability, or it may have some recommendation or suggestion it will gives, or it may do some forecasting. So these are all the outcomes of AI application. These are all few outcomes of AI app. It may predict something even in our Gmail. What is happening? If you like put hi, then it will gives us hi ma'am or sir, or maybe the name of the person we are actually trying to from the receiver end. It will fetch the name of the person. Let us take Prince. So likewise, hi Prince. It will suggest Prince as the text, the next text. So this is how it will generate the next text. So for every AI app, it will either predict something or recommend something or suggest something, or it will, if it is a like it has some year and time series data, then it is used to forecast the value. Okay, this is how the AI application will works. Now, what is our ultimate aim is, if you feed the weight, then our AI application or ML model going to predict the height of the person. So here Y is the output and X is the input. If we feed the weight of the person, then our ML system or ML model or AI application is going to predict the height of the person. How it is possible? Yes, Prince.
I think it's mostly based on the training data.
With the help of training data, how it is possible? That will be the next question.
The data will multiply by the weights.
Okay. So
Can I go ahead?
Yes, please.
So when we say a training, basically there is a mathematics applied in behind of, there is a variability that actually applies, and if the a specific pattern that comes more than 60%, then it actually assesses that, okay, this number is, this kind of pair is coming more than a specific benchmark, then it means so someone having a 170 as a height and similar kind of numbers are coming, and there will be a probability on top of it, and based on the probabilities identify a specific pattern out of this data, and then when we feed a new data on top of it, it actually go back and see whether it falls into the same probability or it is near to that probability, and it actually gives the results, whether it is whether it should have the high weight like 78 or 80 or something like that. I don't. I know I couldn't explain it well, but this is what my understanding, that there's a mathematics involved in it.
Yes, absolutely. There is mathematics. Yes, 2 more participants has raised. I don't know who are them. Yes, you can please unmute and talk.
Yeah, but I was just responding to the last comment. Isn't that just simple mathematics and not really AI, since you have solid computable data and you're just applying, like a probability, standard deviation and that type of thing? Is that real AI?
Yes, actually what is happening is, if it is a static equation, then it is not the AI. It is a simple mathematical equation, exactly as you pointed out. If for example, in our case,
Thank you.
Okay, in our case, what will happen means, since the output that is high numerical value, it comes under a regression model. Okay, since the output is a numerical value, it comes under regression model. So I may choose a linear regression as the algorithm. Let us take linear regression algorithm. So in that case, linear regression has its own mathematical model, like it's a simple straight line equation, y equal to mx plus c. So linear regression algorithm rely on y equal to mx plus c. Okay, so x is the input and y is the output. In our case, yes, absolutely, we have only one input. What is the input? Weight is the input. If you had more number of inputs, then the equation may vary, like m equal to m1x1 plus m2x2. Like, yes, it becomes a polynomial equation. m3x3, likewise it will move on, like based on the number of inputs, like x1, x2 and x3. In our case, it is very simple. Weight is the only input. Okay, so it is simply mx plus c. Yes, our since we are assume that we are trying to apply linear regression algorithm, so the equation behind linear regression is y equal to mx plus c. In our case, after the successful training, how it looks like means this generic equation, how it looks like means the height is equal to, let us take something like 1.3 into weight plus 1 kg. So we know the weight value. Whenever the user feeds the weight value, then it will be multiplied by 1.3x into, 1.3 into weight plus 1 kg. That will be the height. This is how the prediction will happen. So this is what this equation is referred as a ML model. This equation deriving the value of m and c, we are trying to derive the value of or weightage. Let us take in a simple term the weightage of m and c with the help of data and applying ML algorithm on top of data. By applying ML algorithm on top of data, we are trying to identify the pattern, like how far each input plays a significant role in the output. With respect to, it is better to understand if you had like more input variable. With respect to diabetes, we may have the inputs like glucose, BMI, age, gender, pregnancy parameter, etc., etc. It will move on. The output, maybe the output or target variable is outcome. So the final output may be either 0 or 1, whether the patient is diabetes or non-diabetic. In this case, so this is our input. Okay, these are all input variables. This is what the output variable is. Okay, so in this diabetes data set, how the equation may vary means, like sometimes the gender and let us take the gender and pregnancy may have some negligible significance in predicting the outcome. Okay, in that case we are not going to take this into the account. Okay, let us have glucose plays the major role in prediction of diabetes. Okay, so 0.5 into glucose level plus some 0.3 into BMI plus 0.2 of age is equal to some value will be there. So if everything is more than 0.5, then person is a diabetes. If it is less than 0.5, then it is non-diabetes patient. Like that, we'll try to classify the patient, like whether it is a diabetes or the patient has a diabetes or not. So this is what actually the ML model is, predicting the or deriving the coefficients by having the input versus the output. Is it clear now how the predictions or recommendations are happening with the help of ML model? I know very well, like you have not completed any of the courses with respect to ML or DL, etc., etc. So that's the reason I have given a simple words, by using the simple words, trying to explain what is ML model, irrespective of pointing out many algorithms and like naive Bayes, exam, etc., like the probabilistic model and maybe the decision tree and all. Okay, I hope you understand this. Or any more clarification needed? What is ML model and how it's useful for the prediction or recommendation?
Can I try explain?
Yes, please.
Okay, so I'll use a simple English language. Like the sentence, Mary has a little, what's the next word? Okay, we don't know. Mary has a little. Okay, so what happens is that the ML will use Mary, and in this data set, has a little, and then it will put all these words together in an equation, like your y is equals to m1, mx1, mx2, mx3, and then you'll come up with a probability that the final word that will come out is lamb, L-A-M-B. So it will give you an output of Mary has a little lamb. In your picture over here, you show diabetes, glucose level, BMI, age, gender, and maybe the weight. So you'll take all this data, like Mary has a little, then you'll calculate all the probabilities, calculate the probability what the next word will be, or what the output will be, whether it's 1, diabetic, or 0, non-diabetic, the outcome. So I'm trying to explain in the simplest English word sentence and how AI actually come out with the final answer, either a lamb or 1 or 0 here. It's probability, it's mathematical. It doesn't think by itself, it doesn't have emotions.
Yes, absolutely.
I hope the answer.
Yeah. So this is how the generating the text generation will works, right? Yeah. So is it clear? Or so what is AI application? How the AI application related to ML model? Yes, sir, please.
Okay, so training the ML model is simply a way of using different algorithms to code the data in a way that it can be used to make predictions, right?
Yes.
So depending on the type of data, that you're presented with, you would choose a different algorithm that's designed for that kind of data. And then you use that to code it in a way. And then however you code it, which becomes the model, you need something that understands that model to then be able to reinterpret it back into whether it's an image or a sentence or a formula or code, right? To me, you have to have something that understands the specific model that is created. Is that correct?
Yes, like let us take Sam has raised the hands. Yes, please.
So when just now you mentioned about training the model. Training the model, you feed in thousands and thousands of data or documents. It's actually changing the weight, the weightage inside the formula y equals to mx plus c. So when you feed in more data inside, you are actually changing the weightage of each parameters inside x1, x2, x3, x4. You're changing the parameters, the weightage that's supposed to multiply by each individual, finally giving you an output. So like Mary has a little lamb. Why Mary has a little lamb? There weightage each given to the word. Mary, there's a weightage given to Mary. Has, some weightage is given to has. A weightage is given to a. Little, some weightage given to little. So in the English language, let's say you are trained, then they have all these weights multiplied by each of the individual word. Then finally, the most probable outcome would be lamb. That's why you give the word lamb come up when you
Yes.
train.
Yes, yes. In the text generation, yes, that is what going on. Yeah, that is what happening in LLM. So let us take the same example. For example, so we have developed an ML model, or let us take an A application. So this A application is going to predict the patient has diabetes or not. Okay, let us have assume that we had 100 diabetes patient. Okay, so out of 100 patient, if our model predict 80 of them has diabetes, is it okay? It is like 80% accuracy, right? Is it okay to have 80% accuracy to predict the patient has diabetes? Or we have to improve the model a lot?
Yeah, we have to improve.
Improve, yeah.
Yeah, if not unnecessary.
It's relative.
Yes.
It depends on how accurate. Not using if in other words, if walking into a doctor's office, if the accuracy is higher than 80, well, then you have a problem. But if the accuracy is much lower than 80, then it's not bad.
Okay, fine. Like, so 20% is predicted, like it's a wrong prediction, right? So in that case, those patient has to take unnecessary pills, and yes, it will affect some, yeah, like other body parts. So usually this accuracy is not enough to predict the data or for our diabetes case. Okay, so this is not enough accuracy to deploy this into an AI application, this ML model. We have to improve the ML model. How generally the ML model will be improved means, like with the help of some other algorithm. Instead of choosing algorithm A, yes, we can choose algorithm B or C or D. Likewise, it will move on. Like, and and more the things are involved, since it is not an ML class. So I don't want to mention how the data preparation is going on and how the ML like algorithm supposed to like build the ML model, etc., etc. Okay, but this is how it will work. Now I hope you understand like what is the difference between application versus AI application, and what is the relation between AI application versus the ML model. Okay, and what is the reason for having like that role of data in developing ML model, and finally it will deploy into an application. Like, you can understand how the data plays a crucial role in AI application. Am I right?
Yes.
So
So
since
quick question on
yeah,
just one question, sir. In terms of like as a business manager, what kind of like there seems to be different types of models, right? What are the considerations to choosing the kind of model in order to make like a better AI application? Like what considerations go into it? It seems like some are simple, some are more complex. How do you make those decisions on which model to choose?
yes, like nowadays we have multiple application like that would be support to create an ML model, and even for the deployment it supports, like auto MLs are available. Okay, so I have completed my doctorate in that to optimize the ML ops, like auto ML things, automated pipeline. Okay, so I'm a data engineer. So what will happen in the auto ML means, for the managerial like those who are in the managerial position, it is not like unlike maybe the data scientists, or unlike the ML engineers or data engineers, it is not possible for them to choose the right model for the respective problems and all. Okay, in that case, it is a easy way to feed the data or data set into the into an application that automatically will create the model. But what is the drawback of having ML? You mean auto ML means, yes, it is available in the cloud. Like cloud provides, all the cloud providers has auto ML as a service. Okay, that is ML as a service. Okay, so what is the drawback of having such kind of auto ML means, it is actually costlier. How it is costlier means, for example, even for a simple algorithm, the iteration it took, like we call it as a hyperparameter tuning, it took multiple iteration even for a single algorithm. So in case of classification problem, if you fail to limit the iterations, then it will even for a simple diabetes problem, it took like at least some 5 to 6 hours to build a model. But it is actually not needed at all, but it took all the combinations. It tries to have all the combination, and finally it gives you the good performance output, but it is not actually needed most of the cases. Okay, so yes, we can use a simple AutoML tool. It is available in all the cloud providers as a ML as a service. Okay, and yes, by the way, we can develop the quick prototype. We can validate the data, whether the data is good or not. If the data is poor quality, like the integrity of the data is, yes, you can check the integrity of the data. Also, yes, is it okay to have this data to build the ML model? Okay, so yes, for a quick prototype, it is enough.
Thank you, sir.
Yeah, someone has raised the hand. Yes, please.
Yes, sir. Yeah, this is Jansi here. So, it was my always the understanding AI means it is always using machine learning. Is it not? AI is not always use machine learning, or is it my understanding is wrong?
So let us take its, yes, A application. Yes, A is equal to A application. Yes, A application is equal to, yes, absolutely, it has ML model or DL model, deep learning model. Okay, with
Okay.
model, yeah, with the help of model, yes, it can capable of either prediction or recommendation or forecasting. This is how all the AI application will works. Okay, yes, it is right.
True. Thank you. This is I just want to understand because it's clearly mentioned here in the slide. AI and machine learning integration. It looks like yeah. I thought AI applications like just example like ChatGPT. It was I thought even now also after your explanation. I hope my understanding is correct. ChatGPT is by default using machine learning. So it's keep on learning brand the patterns and yeah, it's getting its model. Is it so?
Yes.
Is there any other application, AI applications without ML or without DL? Is it possible in the world or it is not possible? Any AI applications without ML, without DL?
No way. Without model, yes, it's not an AI application.
Okay. Then
It's a simple.
my understanding is very clear. Yeah. Thank you.
So earlier period, yes, as I said, earlier period in 1970s, yes, it's all about the robotics. Like A means it's a robot of parts. Okay, that is what actually given in this slide. In 1970s, the robotic arm is actually used to fetch. It's for the industrial purpose. It's an industrial robot. Then in 1980s, okay, with the help of microprocessor and microcontroller, the precision may improved. And 1990s, yes, with the help of vision technology, it has improved further. Even we can used in like few healthcare domains. And only after the emergence of like 2000, algorithm plays a role. So in 2000, the algorithms like decision tree or maybe the fuzzy logics, the static algorithms, I am talking about simple if else. Okay, so this plays a role in 2000. Nowadays, yes, we have multiple AI supported algorithms like maybe ML or DL algorithm. With the help of this algorithm, yes, as of now we have reached up to LLMs, right? We are creating our own LLMs or RAG or agentic AI to solve the problems. Okay, so nowadays AI is equal to AI application. Is one of the familiar application is, yes, every day we are using is, yes, absolutely, ChatGPT. Other than that, we had multiple small applications every day we are using. Okay, so this is all about the evolution of AI. Then trying to get into a simple HPC like. So before getting to HPC, I would like to make a point and shall we have a small break now for 10 minutes?
Sure.
Yeah, we'll have a break. Please resume in 10 minutes. So I'm back.
Um, Sir, is it okay? Shall I ask one small question? So
Yes,
regarding
please,
this,
please.
yeah.
Yeah.
So you can see this in Zoom also we have this the tiny AA assistant, is it? So
Yes.
this AA assistant is also using speech to text models like a machine learning or maybe LLMs, I do not know. But this Zoom is building their own LLMs from the scratch, or they get it from open source
It's not
APIs.
LLM. It's not a LLM.
Okay,
It's
okay,
a small AI model to recognize the voice.
okay. So
So
in this case, yeah, sorry.
yes, it uses the DL model, we can say. Since it is a
Okay.
multimedia, either a voice or image or video analytics, it comes under DL. Okay, so instead of ML algorithm, they may use the DL algorithm for the prediction, for the recognition. Okay.
Yeah. So they don't need any data set as a foundation
Absolutely.
for better predictions.
Yes, for the creation of ML model or DL model, we require data.
Okay. So the question is very simple. So this Zoom can get their own foundation data, or they're using something like open source ChatGPT APIs to load the data. Just my brain is working like this. So yeah.
Yes, there is a two part. Like,
Okay.
if you are trying to summarize the thing, then yes, absolutely, it may use some APIs.
Understood that. Yeah.
If it is just a translation of like whatever we are speaking, then it is a simple AI model.
Okay. 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 It is also possible to use both of them at the same time. Also. Okay.
Yes.
Okay. Got it, sir. Thank you. Just a thought of more understanding. Yeah. Thank you. Thanks a lot. Please proceed.
Yes. Thank you. Yeah. I hope everyone is back. Let's start. The screen is still visible, no?
Yes, sir.
Yes.
So in every gap, yeah, in the morning session, I had a breakfast. Now I have completed my dinner within some 10 minutes break. Thanks for a lot and for giving this. And yes, we'll start the session now. I don't know what happens to your case. You may be sleepy because of my lecture. Am I right or wrong?
So far, so good.
No, absolutely no, sir. This is one of the interesting sessions. Sorry, it's very interesting. So no, please continue.
Oh, nice feedback. Yes. But yes, it's quite sleepy in my case. Fine. Again, it's a non-programmatic and the demo-oriented session, non-demo-oriented session. Yes, actually, I have to preach more, I can say. Okay, fine. Let's get into the Moore's law. So who is Moore and all? Like Moore is a co-founder of Intel, and he has given some statement on 1965. In every year, the transistor will be doubled in CPU in every year. And also, he actually restated the statement in 1967, 1965 and 1975. It is not every year, it is actually every 2 years. Okay, so every 2 years, the transistor will be doubled in CPU. That is about the processor, whatever we are talking about. So what is the relation between processor and transistor means more number of processor, then yes, actually the CPU power is also more. Okay, so it's not this more, M-O-R-E, more. Okay, fine. So the statement is true. The 1975, the statement is true up to 2015. For every 2 years, actually, the transistor is you mean the number of transistors is doubled in CPU. Okay, I will show you the graph. But after 2015, it slows down. After 2015, it slows down because of the limitation. Yes, because of quantum tunneling and heat dissipation and all. Because like now, nanometer means, assume it's like a size of the hair. Assume that size of the hair is a size of the hair in which a small grain is the nanometer. Okay, in a hair, a small grain is a nanometer. So we had, now we reached up to this spacing, like the space between two transistors is 2 nanometer. We have reached up to this level. Okay, so it is not possible to decrease the space further. What will happen if you decrease the space further means it results in the heat dissipation, or like the leakage is there, power leakage will be there. Likewise, we had some physical limitations. So that's the reason it is not possible to decrease further immediately after 2015. Okay, yeah. So this is what I have given. Nowadays, like what is happening now? NVIDIA A100 or H100 GPU has 80 billion transistor in it. 80 billion transistor. Okay, so this is how the relation between the transistor and CPU is, like the relation between the transistor and CPU is. Now coming back to like HPC, or coming back to the evolution of computing. Okay, what is evolution of computing, or try to understand the cluster computing, distributed computing, and grid computing, or maybe the cloud. Will move on to the cloud instead of grid. Okay, what is cluster computing means? We are trying to group the physical system. Again, I'm talking about the physical system. Physical system means, again, it may be a laptop or desktop system. I'm talking about it may be a laptop or desktop system. Physically, we are grouping the laptop or desktop system within networks. What is the term mean by within network? Means like within the router space, or within some premises, or within a campus, within an enterprise. Okay, within few geographical location, like that. So within a network, if you group the systems together to solve the problem, then this is referred as a cluster computing. Why we prefer cluster computing? Since it is not possible to solve this problem with the help of my laptop or systems alone. So that's the reason I just try to aggregate the power by clubbing the systems together. Again, I'm talking about physical system. Clubbing the physical systems together within a premise, within my premise, or within a network, then it is referred as a cluster system. That is a cluster computing. Now moving on to distributed computing. What is distributed computing means? Almost it looks like same, but with simple differences. Here it can capable of communicate over network, that is with internet. This may be in one location, or maybe in one state, or this may be in another state or another city, and this group may be in another city. Everything is actually working like a single system, and everything works together. So this kind of computation, like here everything within network, but here everything works over in network. That is what we refer as internet. So this kind of like aggregation, or this kind of architecture is referred as a distributed computing. I hope you understand what is the difference between cluster and distributed. Is it true? Shall I move forward?
Yeah.
So now coming on to, okay, I don't want, yes, fine. So coming on to the cloud. I know most of them uses cloud or used cloud. Now give me a give me an example. What is the reason for choosing cloud? Why we are using, or why we are choosing cloud?
Improving data storage.
Yes, for storage we are choosing cloud. Then
Dynamic, the ability to
Scalability, so cloud can go beyond the limit.
yes, scalability, yes. Dynamic scaling, scalability matters. Then
complexity, security.
Complexity. Okay, we can solve the complex problem with the help of, yes, huge computation power. Again. Okay.
You pay only for what you use.
Exactly. Pay per usage, maybe as per usage. Yes, we are not going to purchase hardware. We are not going to purchase softwares. We are not going to maintain those hardware with respect. Let us take a simple example. Maybe any of the DBMS software. Okay. Or simply you can assume some software. Okay. We are not going to bother about like where we are going to deploy this software, or we are not going to purchase the software, or we are not going to bother about the versions and the upgradation of the software. So likewise, so it usually deals with the infrastructure as a service. It gives everything as a service, like XaaS. Generally it is referred as a IaaS, PaaS and SaaS, like infra as a service, platform as a service, and software as a service. In general, cloud is equal to XaaS, that is anything as a service. Even we can get ML as a service. This is what we referred as a auto ML. Okay, so yeah, so likewise we can get everything as a service, and we are going to pay for the service usage. So cloud, yes, absolutely, cloud is also there. And why we are actually trying to compare cloud, HPC, and GPU, CPU? Yes, you can understand everything together by a simple example. Okay, like it's a right time to get into the HPC. What is HPC means? Yes, absolutely, it's a aggregation of huge power. It's a aggregation of huge power. Like for example, it's not the aggregation of system. Again, computer system, as like earlier example, as like cluster system or distributed computing. Okay, so it's aggregation of huge computation power. For example, we have discussed about something related to motherboard. For motherboard, let us take this is a node in a HPC. Again, node means it's not a like. Okay, I would like to point out one more thing with respect to the node. Okay, with respect to the cluster computing, usually what will happen means cluster computing, how to group the computer means we had a small software. Maybe the software, usually the very familiar software is Beowulf cluster. And this software, by having this software, yes, we can club the systems together, group the systems together. Okay, so likewise in the distributed system, very famous or familiar software is Hadoop. By having this software, for example, if you had a 100 system, if you install Hadoop in all the 100 system, and we can configure one system as a master and another system as a slaves, then we call this as a name node and data node. I don't want to confuse these terms and terminologies now. Let us assume one as a master node, another as slave node. Okay, as per master instruction, slaves are actually do the storage as well as process the data. Okay, so as per the master instruction. So how we are actually grouping the systems together? For grouping the systems together, we need a kind of coordinator or a software. In the distributed system, yes, Hadoop is one of the most familiar software. By using this software, by installing the software in all the hardwares, by making or by configuring the systems, one as a or few systems as a master and few others or rest of the things as a slave. Okay, by the way, it will coordinate together and it will give the aggregate results. Okay, by the way, it solves the common problem and aggregate the results. Is it understandable how we are actually grouping the systems together? It is not only possible with the help of only the connection between LAN or WAN, with the help of network components alone.
Yeah.
Yes.
Yeah, thanks. Then we'll move on to HPC now. In HPC also, yes, this kind of grouping is there, but here we are not going to group the computer system, physical machine. We are trying to group the computational unit. Computational unit means like, let us take again the motherboard. The motherboard in terms of, I am talking in terms of HPC. HPC has its own like motherboard. It designed in a way it can capable of accommodating. Let us assume that our motherboard can capable of accommodating to like 128 GB RAM. Usually our system has 16 GB or maybe 32 GB RAM. not more than that, I hope. Okay, but for each motherboard in HPC, assume that it can capable of holding 128 GB of RAM, 2 slots. Then in each motherboard, we can accommodate 256 GB RAM. Likewise, and let us assume again CPU cores. Each motherboard can handle or can we can fix 100 cores of 100 cores in each motherboard. Okay, in such cases, if you had 10 nodes or 10 motherboards, what will happen? The computation is huge, right? 256 GB into 10, so 2560 GB of RAM. Am I right? It's a very simple computation unit, or it's a huge or enormous? Yes, please. Yes, Jeff.
In practice, is maxing out memory actually done, or is there kind of an optimal, and you don't necessarily go with the maximum that one CPU in terms of high performance computing? When you have all those systems, is the memory maxed out in, say, every subsystem?
So yeah, HPC is actually, it's not a generic machine. So it's we have created or developed an HPC based on the use cases. Sometimes the HPC may be IO oriented, sometimes the HPC may be memory oriented device, or sometimes it may be the intensive computation oriented device. So based on that, we have to develop the HPC. Okay, so HPC is, again, it's not a generic machine. Again, why we move on to HPC? Again, absolutely, we are not going to, for our project, it is not at all needed. For our AI project, with respect to our thesis, okay, HPC is not at all needed. Okay, we need a simple GPU with few cores, like maybe, according to me, maybe M1 or M2, even M1 is enough. Okay, if you want to speed up your process, yes, M4 is enough, because Apple M4 has I think I am not wrong, maybe approximately some 10 cores of GPU or CPU with 8 cores of GPU or CPU. I forget exactly the ratio. Okay, it's enough for us to complete our project. Okay, so that is enough. So there is no need of HPC at all. Okay, so HPC has, yes, the combination of GPU, CPU together with a huge computational unit of memory, as well as the cores, etc., with the transfer speed of network is also something more than that of anything. Okay, so one more question here, HPC versus supercomputer. So which one is superior, HPC or supercomputer? HPC or supercomputer, or both are same?
I would say supercomputer is superior. HPC may be HPC may be useful for some simpler problems, and which requires a large amount of data to be processed in parallel. But supercomputers can perform more complex, can solve more complex problems.
Okay. So what about others? Which one is superior, like HPC or supercomputer, or both are same?
HPC, because of scalability.
Yes.
So can I answer?
Yes, please.
So what I think about HPC and supercomputer, HPC is it itself a single unit, like a machine. But in supercomputer, it's a collection of HPC. So in that case, I would say supercomputers are more powerful than the HPC.
Okay. Sam, yes, please.
I think the supercomputer is like a Formula One car. It's a very, very fast car. Whereas the HPC is like you are renting many fast cars that are running together. They serve different purpose.
Okay. So the thing is, in general, like supercomputer is one of the HPC, but we are using the term supercomputer like to make some differences, like since the computation power, whatever the HPC, if the HPC has something enormous power, then it is actually referred as some special type of HPC is referred as supercomputer. But by default, supercomputer is also an HPC. Supercomputer is a HPC. It follows the HPC architecture. But only few systems are referred as supercomputer. That's all. It's just a name. Technically, it is an HPC. Yeah. So then moving on to the need of HPC. Yes, absolutely. There are processor limitation. That is what we have discussed. It is not possible to add more number of transistor into the CPU because of if you align the CPU in such a way, it is not easy to reduce the spacing between the nanometer, like the spacing between the transistor. Okay. So these are the limitation, one limitation. Then another one, it is not possible to accommodate more cores on the motherboard. So these are all the processor and memory limitation. Memory limitation is also same. It is not possible to accommodate more memory, like more RAM into the same like motherboard. Okay. Likewise, let's coming to the storage part. Again, I would like to have some a small case here. Like let us assume that 1000 GB of data we would like to read. With the help of hard disk, assume that 3 hours is taken to read this data. With the help of SSD, it took 1/6 of 3 hours. That is 30 minutes to read the data. Then in NVMe is again 1/6 of, so it takes some 5 minutes to read the data. In HPC file system, I think it is GPFS. Okay. Either it may be GB or GP. I'm not sure about it. In HPC supported file system. Okay. So it's comes like general parallel file system. Okay. So how much time it will take in HPC with the help of this file system to complete the process to read 1000 GB of data? Any intelligent guesses? So I'm waiting for your answers. Am I audible?
Yes, sir. I mean, it should be much faster, but I guess it depends on the configuration, right, sir?
No, let us assume that again, configuration is same across all the, like other than storage units, the configurations are same.
Okay.
Maybe 1 second.
1 second. Wow. If it is 1 second, how it is possible, sir?
So maybe because it's a configuration is same, so I'm assuming it's a 1000 GB HPC system.
You know, one more thing I'd like to mention, the GPFS. HPC also uses NVMe as its storage unit.
Okay.
Okay. So in a ratio, maybe it may be some 20 seconds. Is it believable? Within 20 seconds, it can capable of doing 1000, that is IO operation I'm talking about. 1000 GB of read operation it can complete.
That's impressive.
Because it's based on the number of nodes. It has GPU. Again, like the number of cores inside the GPU is, yes, numbers is high. So in such cases, what will happen is, yes, assume that you may have some 10,000 nodes or maybe some 1,000 nodes. Then at the same time, we can fetch data from 1,000 nodes. Though we are using NVMe, it is not possible in our laptop. The number of cores in the laptop is smaller than that of, yes, HPC. But the number of cores in the HPC is something more numbers. So based on the nodes, yes, absolutely, the speed of the file system or read operation may increase. So yes, it is possible. It is possible to complete 1000 GB of read within 20 seconds. This is what we refer as a parallelism.
Thanks.
Yeah. Fine. So this we have completed. We'll move on to, yeah, this is all about earlier how many transistors are there in the maybe 1970, I think. Okay. So from 5,000 to nowadays it is 50 billion transistor. Okay. This is up to 2020. It is not up to 2025. Okay. It's a earlier like picture. So it shows up to 2020. It is something 50. Just now we have described it is now some 80 billion transistor is available in NVIDIA H100. Okay, fine. Likewise, it will move on. Let's get into the cores in HPC. Again, the ratio of CPU and GPU is vary based on the HPC setup. For the general purpose HPC, like we may have 8 GPU versus 1 CPU. 8 GPU versus 1 CPU to 16 GPU versus 1 CPU. For the AI/ML training, yes, 4:1. For the scientific application, yes, it is 16:1. Likewise, it will vary the ratio of GPU and CPU based on the HPC setup or based on the use cases. So this is what actually I have given. And is it clear? Like how the ratio of CPU and GPU will differ based on the use cases. It's very simple, right? If you had more number of parallel processing is needed, then the need of GPU is more. If less number of parallel processing is there, then yes, we can have less number of GPU. That is the direct answer. Fine. So this is what actually we have described. Like if we had more number of cores, like with the help of GPU, yes, it is easy for us to complete the process. Okay. So then coming for the HPC, fine. Let's get into the use cases. Okay. So this is one of the beautiful use cases of HPC, like weather forecasting. With respect to weather forecasting, yes, absolutely supercomputer is used for weather forecasting. And again, supercomputing is one of the HPC. Okay, fine. What is the role of HPC in weather forecasting means? Let's divide the nation into multiple grids. Okay, let's divide the nation into multiple grids, and in every grid we are trying to receive the information from the respective locations. Okay, let us assume that some 10 cross 10 kilometers. Okay, so the respective input will be the respective input will be moved on to the respective core, and it will process the data collectively and will forecast for the respective location or the forecast for the whole country itself. Likewise, if the application like demanded, then only we need a HPC or supercomputing. It is not needed for actually for the simple application or even for simple enterprise application, particularly for the AI kind of application, because AI application GPU is enough. As I mentioned, yes, M4 is enough mostly, since it has at least some 8 GPU or 10 GPU with 8 CPU. Yes, it is absolutely enough. Okay, so HPC is for something different. The purpose of HPC is something more scientific oriented or more intensive workload. Again, yes, please.
Yes, so you mentioned about it depends on the applications. Might be I would like to understand about the business context. For example, you can take this companies like Nestle, the biggest chocolate and all the companies like Nestle. Do you think if they are accompanying this AI into their organization's process, uh, do they need to have this kind of a bigger hardwares also, or is it okay to run this in the normal processing units? Yeah, how can we put this into the business context? Is there any big organizations are using the supercomputers? Yeah, can you give some
No.
example on this?
Only very few supercomputers are available in the world. So now you can easily understand how to interpret HPC. Is it really needed?
Understood that. Yeah, then it's clear. So
Yeah. So
yeah,
only
I understood
again,
that now.
only
Yeah.
few nations actually build their supercomputers. I think it is something only 5 nations has built their supercomputer, and so this is how the supercomputer is like. It's not an easy thing. Again, the cost of supercomputer is something huge. So that's the reason we are trying to aggregate the power with the help of some by having the cluster computing or by having the distributed computing and all, by using the resources, by using the resources whatever we have together, by aggregating the power instead of building the own HPCs. These are alternate for HPC actually.
I understood, sir. Might be I would ask this question also. I do not know whether it's a proper place to ask, but still, I'm bringing the same Nestle's case. So imagine that if I am, running my business processes on AWS. If they are providing this, web services in the back end, are they using, these vendors like AWS
Absolutely, they will.
or maybe other vendors? Are they using this kind of, okay, in their data center? Is it? Yeah.
Yes, based on the requirement, how it will happen means they may have huge number of processor, etc., and the servers we can say like they had a server in many locations, like multiple locations. For example, when you take the nation India, in India may have several regions like South India had the data centers at Chennai as well as and Hyderabad. Then Central India, yes, we had a data center, like they had a data center at Pune. Okay. So likewise, West India has a data center. I forget the place. Okay. So likewise, they had data centers at regional levels. Okay. So and each data center, yes, absolutely, it is built with some more power and based on the user requirement. Maybe we are not record the whole power. Okay. So whatever the power which is available in the data center. So with the help of virtualization is the technique. Yes, or we call it as a hypervisor. With the help of hypervisor, based on our requirement, we made it some 64 GB of RAM. Usually it is not possible in our laptop, or let us take 128 GB of RAM. So based on some 2560 GB of one node, or maybe 100 nodes, let us take. So they will actually split this, or they may actually split this 126 GB that is what I am talking, like 128 GB, and will actually provide for the respective user, and we are using those resources with the help of virtualization or with the help of hypervisor. Okay, this is how it will works. Yes, it has multiple data centers, and actually it is not a HPC.
Yep, understood.
Yeah. Then again for drug discovery. So I'm not a person from medical domain. Again, in the drug discovery, what will happen means, so we have to stop the replica of virus. How to stop the replica of virus means, then we have to find out the protein like the molecules, and we have to inject the drug molecule into the protein molecule. Like one of the senior person who informed me during the discussion, there are billions of molecules which is available in a virus, as well as the billion of components is also available in a drug. Okay, so this kind of iteration will happen, like we have to inject 1 to 1, like that we have to test from billions versus billions. So it is not an easy thing. it's not easy with the help of some like physical lab support and all. In such cases, yes, we have to do this synthesis with the help of HPC alone. Okay, so for this kind of intensive application, yes, absolutely we need HPC. Then yeah, instead of going through all this, yeah, someone has raised the hand. Yes, please.
So did Pfizer actually divulge that they use HPC to come out very quickly with their COVID vaccines?
Yes, absolutely.
Thank you.
So those who are having, those nations are having their own supercomputer. Yes, they have built it or they are supported for the drug discovery. Yes, absolutely.
Thank you.
What will happen means they may take this as a rental, like a supercomputer may be available as a rental, and the pharma companies may use this supercomputer, and they may like a cloud. Based on the usage, they will the cost may vary. Okay, likewise it will move on. Like fine, this is a very simple table to understand how far the simple i7 laptop as well as the HPC differs from each other. With respect to CPU performance, it is simply 100x than that of i7 laptop. GPU, yes, absolutely 100. Again, RAM 250x. Storage is something, see, 1000x more than that of our laptop. The speed I'm talking, speed as well as the size. With respect to network speed also, it is something unbelievable. 400x faster than that of our laptop. Okay, why this is actually 1000x? How it is possible 1000x faster than that of our laptop? This is what actually we have discussed. So it is completely based on the number of nodes. If the number of nodes is higher, yes, then the speed is also higher. Fine. Then have a look over it, like what is the difference between HPC and cloud. I'm not going to go line by line. I will take a pause for 2 minutes. Just go through it. Let me know, is there any doubt in this? Where is the term financial risk?
Are they using HPC to determine financial risks like stock market competitiveness of American companies?
No, I just want to know, like this word is available in this slide actually, or?
Okay. All right.
No, if you would like to pose the question, yes, you can. Like, I think this is available in the slide. I'm searching for it. That's the reason. Yeah. So HPC is costlier. Supercomputer is costlier. That's the reason we are trying to go with some cluster computing or distributed computing to club the systems or aggregate the power to do the task. Yes, please, Prince.
Sir, the second second line in the slide, because in cloud computing we have a hypervisor, right, which actually does the logical segregation of the resources across the different machines which we need, right?
Yes.
The storage specifically. But in HPC, because it's a single unit itself, right? It's a very, and if we want to make a segregation, I don't get this point. Typically, bare metal in the tightly coupled system with a job scheduler. This is something that I would like to explain a bit. So can you please help with that?
Yes. What is the meaning of tightly coupled means? There are two terms like tightly coupled and loosely coupled. So what is the meaning of tightly coupled means? if the processor can able to access, if you are grouping the systems together, after grouping the physical system, if you allow the systems can able to access your resources, that is access your memory, I'm talking about memory, RAM, okay, directly, then it is referred as a tightly coupled system. If it doesn't has the power of accessing RAM, then it is referred as a loosely coupled system. Since HPC works as a it's a aggregation of, even though it is an aggregation of multiple units of power, it works as a single system. Okay, so since it is that, if it is a tightly coupled system, then only it is possible to interact with other nodes, memory, and yeah, it can able to complete the job. But HPC has its own structure or architecture, it may have the batch system in the front end. The user will always interact with the batch system, and the batch system has multiple supporting units, like scheduler will be available, load balancer will be available. So what is the role of load balancer means, if a job failure happens in one node, then that job will be move on to some other nodes for the completion. Or if the particular node is overloaded, then we can migrate, the job will be migrated to some other node with the help of load balancer. So likewise, we had architecture in HPC, it has multiple units like load balancer, scheduler, batch system is the entry point for the cloud, for the users, HPC user. Only with the help of batch system, the HPC user interact and get the results. Okay, so this is how it will works.
So in terms of differences between HPC and cloud, can the same kind of capability as far as computing is concerned achieved through cloud?
Nowadays, from the last year, I think HPC as a service is available in cloud nowadays. If you try to create a computation service, that is VM, I'm talking about virtual machine service. Earlier we have only IO oriented or memory oriented, as well as we had a different virtual machine based on that. Nowadays we have HPC oriented. HPC is one of the bucket in cloud. HPC is available as a service in cloud. Yes, we can make use of HPC as a service, and yes, we can do the jobs, but it is not unlike supercomputer. It is not exactly like a supercomputer. Again, supercomputer is something, yeah.
I mean, latency will be
Latency will be very less. Yes, absolutely. Again, the cost also matters.
Got it. Thank you, sir.
Yes, Sam, please.
Can I summarize this slide saying that if you can wait for the answer, you can use the cloud. But if you need your answers very, very quickly, high throughput, low latency, then you use HPC.
Yes, absolutely. Always the cloud depends on, or the backbone of cloud, we can say, technically it is a backbone of cloud is virtualization. Okay, but actually the backbone of cloud, according to me, it's actually the network speed. Internet speed is the backbone. The latency matters again, and even everyone will notice, if you look at our task manager in the Windows machine, or maybe how far we are using the resources in our system. Usually it will be less than that of some 50%. With respect to HPC, or we need HPC, we are going to use 24/7. Are we going to use the resources, or the resource utilization is like that? That will be a biggest question marks, because HPC is costliest one. Okay, so yeah, based on the usage, again, based on the use cases, yes, we have to prefer either HPC or cloud, along with your point. Yes.
Thank you.
Yeah. So this is also we have explained what is the difference between CPU and GPU. Yes, if you had a general purpose computing, yes, CPU is the thing and it is the master. It handles it handles the instruction in a sequential manner. Yes, but it is not look like sequential for us. As we discussed, the clock speed is something more like 3.9 into 10 to the power 9 cycles per second, 3.6, sorry, into 10 to the power 9 cycles. In case of 4 core, that is i5 processor, it is something 4 into 2.4 gigahertz. So it's not, even though it is sequential manner, it's not look like sequential for us. Okay. So if you had a parallel, if you need of parallel computation, yes, absolutely GPU is needed. In case of our AI project, if you are trying to do something cognitive thing like image analytics or video analytics, or let us take a beautiful example of surveillance, like the camera used for surveillance, then that camera has to identify the real-time monitoring and has to identify the faces means, yes, for that we need a HPC, okay, or GPU, sorry, not HPC exactly, GPU. For that we need some GPU with a number of cores, okay. So this is how the GPU and CPU differs from each other. It's again based on the AI projects. Not all the AI projects requires GPU. Only few projects require, or maybe for a few weeks we may need GPU, not more than that, only during the training or validations. With respect to even for AI creation or AI agent creation, again. So the clock speed, yeah, here I have mentioned the clock speed of GPU versus CPU. Yes, absolutely, the clock speed of individual core in CPU is higher, but individual core of GPU is lower because we had many cores in GPU. That's the reason. Okay, that is what actually given in this. And getting onto the fault tolerant mechanism of HPC. We have already discussed about checkpoint. What is checkpoint? What is checkpoint? If some failure happens, we are not going to start from the first, not going to start from first. We are going to start from the latest stage where we have taken the checkpoint. It's a simple rollback where we have saved the things. Then the distributed system, like what will happen in the distributed system is, so most of the distributed system has the replica factor. For example, if you try to save the file a.xlsx, then usually in the distributed system, what will happen means it try to save this file in, it is not exactly, but for an for a simple namesake, I will give you say a simple example. For example, the a.xlsx is going to save in a node 1. Then if the replica factor, if we set as 3, then it will take the duplicate of a.xlx in 3 other nodes. If one node failure happens, we can easily recover the data from other nodes. Okay, it is actually not true exactly, because usually how it will happen means the file is divided into blocks and the blocks are segregated amongst the nodes. Okay, maybe for our simple explanation, we can take the a.xl is available in or try to store in a some particular node, and the replica is available in some other nodes. Okay, fine. I hope it is very clear. Then yes, job scheduler recovery, I told like load balancer is available. It will continuously monitor the jobs, and based on the job failure, it will tries to migrate the job into like some other nodes, etc. So this is how the failure is actually tolerated, or the fault tolerance is appears in HPC. Then moving on to the last slide. So how to take care of or purchase the HPC? Okay. So again, usually we are not going to do that. Okay. So these are some of the parameters. Like if it is the memory oriented, then it should be, we have to select the RAM accordingly. If it is a like intensive jobs, computing intensive job, then we have to select the core GPU versus GPU based on the parallelism. Okay, whatever we needed. Okay, likewise budget matters, like whether we are going everything with the help of HPC, or we are trying to have our own cloud, or maybe like it's better to have on-premise server. Likewise, so budget matters. Then the vendor also plays a huge role. Like everyone knows, everyone may come across the term like Cray supercomputer. Okay, so this is one of the supercomputer which is used for weather forecasting. And if some vendors are good in doing some specific application, if they are superior in that, then we have to select the respective vendors. Like that, we had some parameters. Okay, so this is again one more generic slide, not a too technical point we had here. So this is the last slide, and yeah, that's all right. Time is there or still? Okay. Yes, Sam, please.
So you mentioned all these companies here and the all the technology is an American, like Dell, Cray, Nvidia. What about the Chinese? And who is really winning? Is the US winning the race or is China winning the race?
Absolutely, I don't know. So, so you are actually you try to understand, I think, the current
Because
situation.
we will try to buy systems, either from the Americans or from the Chinese. So I don't want them to BS me when we design systems or the architecture of our systems.
Okay, as of now, NVIDIA plays a huge role in GPU. It may be the answer right now.
The only answer?
Yeah, that's all right.
Huh? Oh,
Yeah,
wow.
right.
Wow. Okay. No wonder.
Yes.
Oh dear. Thank you.
Yeah, even I am not aware of like NVIDIA belongs to which nation. Okay. Yes. Yes, that's all
So
about
it
that.
was a disclaimer, sir, right? Is it?
Sir?
It was a disclaimer that you don't know from which country
Yeah,
NVIDIA
absolutely.
belongs to.
Always in the stock market, there will be some disclaimer like
Yeah.
the risk is based on some etc. 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 This is just a teaching and all. Like, yeah. I know that participants are from various nations. Okay. Why? Why I have to state something based on my person?
I think this AI and HPC is going to give a very big unfair advantages to the nations and countries or the companies that own HPC. Very, very big unfair advantage. It can be defense, military, drug discovery, stock market prediction, country GDP prediction, economic models. Wow. Thank you.
Yeah. Okay. So how was the session? Is there anything need to improve more? Like the speed of the session is it's okay, or I'm little speed or little slower than the expectation?
That's fine, sir. That's fine.
It's
This
just
was a
nice.
good session.
It's good.
Interactive. I think you were
We
asking
learned a lot of things.
questions. Yeah, it's good interactive session.
Yeah. Thank you.
It was a quite an engaging session, sir. To be honest, it was very nice, and it actually kept us on that desk for all the time.
You know what
Because
will happen is earlier. So I am the one who actually engaged the cloud session, but I got a reply or I got this guy is more technical and this guy is actually running some services and trying to show the output. We can't able to understand and all. I don't know what to do because I'm a cloud guy as a data engineer and I don't know like where I missed and all. But the same thing for the same batch I have handled HPC. They have given a very good feedback. Something I can't actually tolerate that. Oh God, that is my area. So I don't know where I have missed it. Okay, so I got it like where I missed out and all because of the audience. Like the audience are from various domain. It is better to go with a few technical terms and all. Since I am quite good in cloud and yeah data engineering, I try to post multiple things or try to show as much services I can. But yes, for them it is not easy to follow up. Yeah.
So I think it was good that you got into the fundamentals, in the first half, which was very good because it, I think, set the foundation for the rest of the 2 hours very well by getting into the basic setup of, constitution of computing, etc. I think that foundation was very good for the non-technical people in this cohort.
Yes, ma'am.
Yes, sir. Sometime before the first call, you got the call from Smitra related to the assignment. Okay, so she also could choose technology. That's much enough. So now we got.
Ma'am, your voice is breaking. Ma'am. Same for everyone.
Question, since you said it's a.
Yeah, it's breaking. We can't hear you.
You
The voice is breaking.
Yeah.
Ma'am, can you please post the message in the chat box?
Yeah.
Yeah. So I have given my LinkedIn URL here. Okay, if possible, you can endorse the lecture. Is it okay? So this is the first time I have actually posted and I have request for the endorsement. I have missed multiple sessions.
Sure, sir. Thank you.
Yeah.
Thank you very much, sir.
Yes.
Thank
Thanks.
you, sir.
Thank
This is
you.
very good session.
Yeah, through the sessions,
Thank you.
you guys are
Thank you so much.
helping and very interactive. Yeah.
Thank you.
Thank you,
Good
sir.
night.
Yeah. Thank you.
Thank you very much. Thank you.
Thank
Thank
you.
you,
Good night.
Professor.
Thank you.
Bye. Bye.
Yeah. I don't know. Again, it is a good
Bye,
morning.
sir.
Yeah. Okay. We'll wind up. Thank you all.